it working? Is it working? Cool. Yeah, we're live. No one watching yet. Let me just change the thumbnail. Hello.
Why do you put my photo on it?
I'm putting your photo now. Like, huh?
Oh, I think like I saw you put like Gordon's photo on.
Yeah,
Hold on,
I'm doing it now. Like, I'm putting yours on now. It's like each time I gotta change it at the start.
yeah.
Don't worry
Nah,
about
that's
that.
it.
I'll put you.
I think the photo is probably a bit big.
Yeah, the file's too big, so I gotta like download it in a smaller form. It's kind of annoying, but
And it's a bit laggy. Is it just me?
the stream's gonna be a bit laggy because. Well, what do you mean by laggy?
Oh, I'm watching it right now, and it's not like really flowing well.
Maybe because I'm not on it.
Or maybe it's just me. Well, I don't know. So do you want to start a bit late, like 8:05?
Yeah,
Or
sure.
a bit. Get my cast ready.
Right, hello. I think there's 8 people watching, so hello to you guys.
Yeah.
Hello, Gordon. I think someone else might be popping into this stream today, like a special guest. Like, you don't know, but yeah.
Really?
Yeah. Hopefully. He
Is
said
it
he would.
someone? Is it someone from? Is it someone I know?
Nah. It's like a YouTuber.
Oh, okay. Hello, everyone.
We got a question already, do we? Hello, Sleepy
Yeah.
Pogger. Okay. Do you want to
I think you can get Gordon on tomorrow to do the special exam too. 2 exams in a row.
Well, I'm too tired.
So how many practice exams did I do for method? Not, I think pretty standard, like 20, 30-ish. But I find the VCA ones quite helpful than a lot of the companies one I did. They are like, the questions are sometimes not the best, but nevertheless can give you a bit of extension, I think.
Yeah, for me, I did all the VCAR practice exams plus maybe 6 company exams. And I agree, like doing the company exams, I was a little unmotivated because I felt like I was like, this doesn't feel relevant. And
I think rather than focusing on how many exams you do, like try to learn from every exam. Look at the mistakes you made and look at what you can improve, like the time management or making a lot of silly errors. I think that can really boost your scores up by quite a lot.
Did you make a list of your silly errors, or did you just like?
I kind of, after I do an exam, I write it to the cover, like the marks I lost. Like why did I lose them? I said I don't know, or is it because I made this error?
No, fair. Yeah. Also, thank you guys for 1K subscribers. I don't think I had like a video or anything. So yeah.
1K. That's like a long time ago, guys.
Yeah, I never made like a video, and I don't think I had many live streams since then. But yeah, it wasn't that long ago, honestly. We're almost at 2,000, so thank you guys.
Like I gotta hit 10K answer. It will be a milestone.
Yeah, 10K will be massive milestone. And Brendan's my friend from medicine, and yeah, this YouTuber is like someone who helped me out a little bit when I first started. So hopefully he pops in.
Yeah, improving grades. Darren, do you wanna? Because I kind of I want you to. I'll think about it, and then let's see if you
Sure.
want to take that off first.
Yeah, I mean, for most people who are sort of in that like middle bracket, it's usually like you don't really understand certain concepts, or like yeah, probably that, or you can't do the hard questions a lot. And in that case, I think just spending time to sort of learn it again, and doing like a lot of questions related to that particular topic, and also just doing a lot of hard questions and figuring out like why you got it wrong.
Yeah, I think sometimes our approach to study is a bit not the optimal way. For example, if you talk about math, like if you do it by just memorizing formulas, that's probably the best way, not the best way to go about studying math. You gotta look at the questions, look at the concept, really understand them. Okay, and I think that would be really helpful.
I think we'll answer these questions and then we'll just get started then.
Yeah.
How do you not freak out when you see a question you don't know? What do you suggest doing? More to
I'll answer
concentrate?
that. I'll answer that because
Sure.
I remember in 2020, like there's a method question I didn't understand. Didn't understand what it means, and it really freaked me out. Like I think I ended up in solving it and lost the 2 marks. But then, like it was the moment after I handed in a paper, like sitting at the exam room, I figured out how to do it. But that's just very. But what I did is I kind of skipped that and then keep going, come back, check everything, and then spend time on that question. Yeah. But honestly, if you like do all the practice papers well, do a lot of practice, I don't think it will be too many questions that you don't know entirely. So it should be like the method exams are quite repetitive for some of them.
Yeah, I agree that it's pretty hard to not freak out, especially if like you're a high achiever and you suddenly see a question you don't know. You might be like, "Oh, I'm not going to get like 50 or whatever." But I think you shouldn't. You should think about it in that like if you freak out, you lose a lot of marks probably that you wouldn't otherwise lose, and you'll mess up your other questions as well. Like this is just one question, right? We can do our best for it, or we can come back to it in the end. But you just don't want it to compromise the quality of your other answers as well. And doing more to concentrate more in the exams. I think in year 11, I didn't concentrate that well in the exam. I was thinking too much about like ATAR and study score. I think when you do the exam, for me, I just liked just doing the exam, like just trying to concentrate on the question, how to solve it. With English, like analyzing each like each sentence or each body paragraph in argument analysis, rather than thinking about, oh, I need to get like a 50 or something.
Can I get started?
Yeah, sure, go for it. Which page are we
All
starting?
right. So it should be the first page on section B. So we start the exchange response and then see if we have time for the multiple choice, and then we'll come back. And before I start, I think I would like to point out something in sort of just overall in the entire method exam. That what my tutor told me is that the entire exam can be, or the questions can be sort of classified in 3 levels. So the sort of the mediocre one, like the standard basic ones, and they take about 60%, and the middle level one is a bit further, like advanced practical questions, and they take up about 30%, and the hardest tier would probably take up 10%. Okay, so 60, 30, and 10. And if you want to achieve, let's say 40 above, 40 to 50, 45. Okay, I think getting that first 90%, be confident with those is really important. But if you want to aim for like a 45 plus to 50, then it's really every question you gotta be confident with. And this is sort of the way I did my practice exam. So I look out for those like the 10% really, really hard questions and trying to see, okay, how can I like figure them out every time. So exam 2 is very, you gotta use your CAS a lot. Okay, so every question, if you see an equation, I will define it first of all. Define it in your cast. Okay, whether it's most likely to be very useful. So actually, before the exam, you want to clear all the variables first. And I'll start, okay, defining it. F of x equals x squared times e to the power of negative x squared. Okay, and the first one, like you can do it by hand, but I wouldn't recommend it because, well, if you got a cast, just do it there, right? Okay, so f dash x would equal bracket 2x minus 2x cubed. Oh, Darren, can you move your cursor? Because it's kind of blocking me.
Oh, okay, right. Is that better?
Yeah, now it's better.
Cool.
E to the power of negative x squared. Okay, so maybe after that, like after you finish the exam, you come back, maybe you want to try that using like, I don't know, write it out yourself rather than relying on the cast. But for now, I'll just, keep going. Okay, so this equation, this function, this curve is not a standard one. So maybe what you can do is, okay, put it into the graph and see what it looks like. Okay, and then you'll be much confident with the questions later on. Now, state the nature of the stationary point on the graph of f at the origin. So here, it's obvious that when x equals 0, f dash x or f dash 0 will be 0. So we'll have a stationary point there, and we want to see if it's a local maximum, local minimum, or a stationary point of inflection. And really, if you put it into the graph, like plot it out, you can really see that this is a local minimum. But I'll provide a couple of ways to do it. Darren, I think I'll be writing like below, like here,
okay, cool.
At the bottom of the page to show a couple of ways of doing it. Firstly, you can try double derivative. Oh, actually, is it question BI? So second derivative. Let's compute that. And that's f double dash x equals bracket 4x to the power of 4 minus 10x squared plus 2 e to the power of negative x squared. And then you sub 0 in. Okay, so it should be 2 times e to the power of 0, and that's just 2. So the fact that it's a 2 tells us this will be concave up. Okay, and if you have a concave up function, and then it's a stationary point, then quite obvious it will be a local minimum. But then this method, if you're not 100% confident with second derivative, I would suggest going with other ways, like the gradient, the gradient table, or other method. Okay, so something that I would often do is I'll find all the stationary points and see where they occur. So firstly, we solve f dash x equals 0. This is really easy, right? Just put it into a cast, then you can get the solution. Next step, you look at, okay, so it gives you x equals to negative 1, 0, 1. I want to find the nature when x equals to 0. I know that in the interval negative 1 to 1, okay, so I'm just going to get one stationary point, right, at x equals 0. So what I will do is I will test out f negative 0.1 and f 0.1. And since you defined it, that's really easy. That's about 0.0099. Okay, but the number I don't really care as long as it's a positive value. And I look at f 0.1, again, it's the same thing, right? So in my head, the curve will look something like this at 0, 0, and then it sort of curves up a little bit. Okay, from that, you can deduce straight away that, okay, it will be a local minimum. Okay, so here's a couple of ways. But for the actual writing down, you only need to write really just minimum would be enough. Okay, you don't need to write it 0, 0, but I wrote it, so yeah, maybe it's obvious for you come back and checking as well. All right, so question 2, find the maximum value of the function f and the values of x for which the maximum occurs. Okay, so since there's no boundary to this function, so the absolute max and min must occur at the stationary points. Okay, because well, we don't have a boundary, so we can't really test for endpoints. And we know that 0, 0 is a local minimum. Okay, so now we need to find other stationary points. And as I did below, f dash x equals 0. Oh, you don't really need to write this down. This is really just your sort of the way I think. The top lines really you don't have to write it. F dash x equal to 0 and x equals -1, 0, and 1. And what I'll do is I'll write them all out. -1, f0, 0, f1 equals, I think it will be e to the power of -1 as well. And since we know that, okay, absolute maximum and minimum must occur at one of these 3 points. So I'll just say, okay, then the maximum value, you pick the most one, is e to the power of -1. Okay, and occurs when x equals ±1. Right? So don't forget the ±1. Okay, so it's not just asking for 1 point, it's asking for several, all the points that gives the maximum. And okay, right. For the last question, find the values of d, which is an element of an all real number, for which f of x plus d is always negative. Okay, so I like to think about this plus d as a sort of a translation unit. Okay, you shift the entire curve up or downwards. And if you don't pay attention to it, like plus d, a lot of people would just think of it as shifting upwards, right? But bear in mind that if d is a negative number, it can also move downwards. Okay, shift the entire curve downwards. If you plot it again, like neocast, I think you will see something like this. So y equals 0, and it would look something like. It'll look something like this. Okay, so basically, to make the entire function or the entire curve below always negative, note that, important, very important, not 0. Okay, so if you make it touch 0, then it's not really allowed. So d here has to be a negative number because I want to shift the entire curve down. Okay, but how much do I shift it down by? Well, if I shift it down by e to the power of -1, right, or 1 over e, then I'll just make the local maximum touch the x-axis. So everything below that will be fine. So d is less than 1 over e. Okay, or you can write d is -1. Same thing. Oh, sorry. Here should be a negative because again, you want it to be a negative number. All right. So, Darren, do you think we should start answering some questions?
Yeah, sure. Well, I'll just talk about this briefly, this question. First thing I would say is when you define your equation, you've got to be very careful. I think in both years' exams, and it's a bit embarrassing, I think I defined some things wrong. So I got a couple questions wrong. But yeah, so question 1A, as Yichen said, you can sort of do it by hand if you have time or if you want to, or just to check whether whether you've entered the correct function into your calculator. The second thing is just in general with exam 2s, it's really good. Like you have a lot of ways to check answers, which is awesome. right? Like you can draw the graph to check if it's a minimum. You can find the second derivative, and it's all really quick because you have a calculator. So I do recommend you sort of do different ways of the same question just to check whether your answer is actually right. And similarly with question B3, you can just draw it in your CAS, right? You can just sub in a number less than -1 on E and see if the graph is below to check if your answer is right. Yeah, cool. We can answer the questions, Yichen. You can talk if you'd
I
like.
think there isn't much questions, right?
There were questions a lot earlier. So, oh, thank you, Jennifer, by the way. That's awesome to hear that. My videos are helping you. Prac exams. Yeah, Tony Jojevic.
Where is that?
Oh, that's probably, yeah. It's probably more for me. How many marks dropped from 45 to 46?
Oh,
I think both years I got 46, right? So I dropped around 2 marks exam one. I dropped 2 marks exam one, and I think either 7 or 8 for exam two.
all right. So should we continue to the second page?
Just one more question, I think.
Mm-hmm.
What do you think the difficulty is to get a greater than 95 ATAR?
Oh, very good question, Dan.
You want to answer this first?
I think it really depends. Like if you aim for, depends what you aim for and how much work you put in, right? And to get above, I don't know, it sort of really accumulates back from like year 9, year 10, year 11, all the way to year 12, and see what are your average grades and is there any improvements, right? If you want to aim for like say 95 plus, I don't think it's hard. Okay. Learn your contents and do a lot of practice, put a reasonable amount of effort in. I think that should be a achievable goal, I'd say.
Yeah, I highly agree with you, Chen. A lot of it depends on your background. Like if you're doing well in a private school, then you're gonna like you're sort of in a separate bracket to other people. So it's really hard to gauge the difficulty because it's so different for people in different schools and people from different academic backgrounds. Like I think our school had like 30 people who got above a 99, and like some of my friends who sort of just above 99 would have been like duxers at other schools.
Yeah. And is second derivative allowed in methods? Yeah, I think it's taught in methods, part of the chapter. But even if you use some knowledge in special, I don't think they'll penalize for it as long as you get the right answer. But unless you write some really, really weird and advanced stuff down, like maybe third year uni math stuff, then probably that's not you're gonna get marks taken off. But yeah, second derivative is definitely okay to write that, I think. All right, so Darren, do you want to have a look at C?
Sure. Yeah, I'm at C right now.
Yeah. So find the equation of the tangent to this graph. Well, if x equals to -1, we have a stationary point. Then the equation of the tangent will be y equals. Now, note that this is not y equals -1, okay? It's y equals the y value of that point, of that stationary point. And find the area enclosed by the graph of f and the tangent to the graph of f at x equals -1, correct? 4 different places. Now, that's why you're going to come back to the first page real quick.
Sure.
Yeah, that's why like drawing a graph out when this is something that you're not really comfortable with is good, right? Because if you draw it here, then it's not really touching, but okay. We're really just looking at this area, okay? And that might be really helpful to saying and helps you understanding the question. So, all right, let's come back. Now, after understanding that, all you need to do is area equals -1 to 1. And the top function, which is 1 over e minus f of x dx. Okay. Since it's a 2-mark question, I think it's just asking for the formula and the answer. So I'm not going to bother writing down other stuff. About 0 point, and also remember to circle these 4 decimal places. Like it says in the question bar, right? But still, there are a lot of people who don't pay attention to it. I think it really depends on. I mean, really like your habits can influence your scores a lot. Like you are not used to paying attention to these details, then you're really just losing marks that it's not really hard, right? It's 3 marks. So 0.3568 units squared. And that's, again, one of my habits, but I don't think it's necessary. All right, let's have a look at D.
Yeah, just with 4 decimal places. I think in your CAS there's like a setting called like float or something. I set it to like float like a really big number, like 12 or something. And I'd say like, yeah, set it to a really high number. Because for example, if you set it to 5 decimal places, like the number might be rounded, so you might actually get the wrong answer. So it's good to have as many decimal places as possible. So when you round, you know it's correct.
Yeah. I was just trying to check like what. Yeah, I set it to float A.
Yeah.
If you want, and I've been using that for like a number of years now. So question D, that M and be a point on the graph of F. Okay, so this is a point on the graph of F where M is between 0 and 1. Find the minimum distance between M and the point 0e and the value of M for which this occurs. Okay, that's quite a lot of things we need to answer. So first of all, we need to answer the minimum distance and also the value of M. Okay, make sure you don't omit one of these. So Darren, do you want to come back? Actually, no, I just draw it below the question.
So I agree with Yichen. Sort of with this, drawing the graph is extremely useful because there's so many things going on. If you really take the time to sort of see what does it mean, what is point like what are the boundaries for M between 0 and 1? So the X values have to be in 0 and 1. Sort of seeing where that is will help you understand the question.
Okay, this is not a very well drawn graph. For example, the asymptotes can't touch the curve, and okay, and the origin should really touch, like the local minimum should really touch the origin, but all right, just make it a bit clear. Okay, and the point 0e is somewhere here. Okay, and M is some point in here. Okay, between 0 and 1. And 1, we have the local maximum. So we want this distance to be minimized. So this point M, it could really be here, could really be here, could really be here. I'm looking at, okay, which point is going to give me the minimum distance. So with that in mind, I think it's pretty clear that now we need to first come up with an equation that describes this distance. So first of all, N can be represented or can be written in M squared e to the power of negative M squared. Yeah, okay. So we want to reduce the number of variables as much as we can. So the point M is now reduced to M squared e this. All right. And now the distance. Okay, I'm going to use S here to represent distance because, well, D is kind of used for derivative later. So that will equal distance formula M minus 0 squared plus M squared e to the power of negative M squared minus E squared. And I like looking at that, it's pretty complex, right? But I don't really want to care about it anymore. I just want to go straight into div. Yeah, like you don't have to look at it. Let Cass deal with the situation. And note one thing really important, note one thing here. The domain for F is between 0 to 1. So when we find the value for M, we don't want it to be more than that range, right? So for example, we don't want it to be less than 1 or less than 0. For example, it's gonna have a point between -1 and 0, where it will give you a minimum distance as well. But we want to ignore that. Okay. And after putting that into your cast, I think it will give you m equals 0.783. And again, note the required decimal places. And also, the distance will be 2.511. Okay, I'm not writing much here because I'm letting Cass do all the work for me. Okay, and this is really, I would say, like one of the tricks for exam 2, right? If you go to see the report, most of it have only like 2 or 3 lines. It's not like exam 1 where you need to do a lot of derivations and I know use this formula, use that formula. And in exam 2, you just put it all into your cast, it's more application, right? And write down the results. And this is all you need here.
Yeah, just the reason why you want to convert n to m, in case you like wanted a more solid reason, is that because you have the distance formula and you need to derive it. You can't really derive it if there are 2 variables in there, like particularly methods. So you can't need to put everything in terms of m.
Is there some questions?
Yeah, I think there's quite a few. Let's see. I'll just answer Norman's first. No, Man, I think your name might be. How hard is it to get into med school? Generally, it is hard. It's probably the hardest course to get into, short of like going overseas, because you have really high minimum requirements, and yeah, so it's pretty difficult to get into med school.
All right. So, do you want to share your average mark in year 11, Dan?
Oh, my year 11 was my worst year.
Really?
I'm pretty sure, yeah, because I spent too much time on my 3/4s. I think it was still probably A plus.
Darren doesn't have bad years, guys.
Thank you,
All
Yichen.
his years are pretty high.
Yeah, I think that was the year I didn't come like top 3 or something, like GPA. But yeah, so I think it was still would have been A plus and probably in the 90% range. Spec was a pretty poor and Chem I got like 1A. But the other ones were all A plus.
Yeah, for me, like year 11 wasn't my best year as well. Academically, year 12 was, but yeah. So yeah, remember year 11, like Chinese wasn't giving me a good time. So yeah.
Your ducks.
It's better to do V cup.
You go.
I'll answer the question, and you can come back to the question before. Is it better to do more VCAP methods practice exams than company exams? I think, personally, you should really treat the VCAP exam as sort of foundation of your revision. Okay, all the company papers are really there for extension. Okay, start with the VCAP first. I think some people leave it to the end, right? But like you need to make sure you spend time to do all of it. Then company is just something else that you can maybe challenge yourself to. That would be my take to it. Do you want to answer about the next question?
Yeah, sure. I think definitely there's hope. Like I have someone who tutored me for like a couple lessons a couple years ago as well. She went to a school that was like very like not very academically orientated, and she got 99.95 with like 450s. So I think like it kind of depends on you. Like I don't feel like you should let your school get in the way of what you want to do. Probably you might need, the only thing that might change is you might need some external help. Like you might need some tutoring, or you might want to see people who have done well because you don't have that history at your school. But apart from that, like SACS wise and all that, I would just not really think about that and just do your best.
And is it okay to shorten to f of x in the exam rather than the full equation, as long as f of x is defined previously? Okay, if you define it, then it's basically the same thing. So you can definitely shorten it to f of x rather than writing it down. But make sure you define it first. For minimum and maximum distance, it's really a question about optimization problem. Okay, so or absolute minimum and maximum. And what I did is, okay, so if you have a function, and you want to find the absolute maximum minimum, and normally you see these questions in applications, right? So you don't have the domain to negative infinity to positive infinity. For example, if you want to find volume or like velocity, speed, time, or whatever, the domain is normally restricted, for example, to 0 to infinity or 0 to 10 or whatever. The points that you can compete for maximum and minimum is the endpoints and also the stationary points. So you just need to check those points and see which one is the best of the maximum and which one is the minimum. Then, well, that's how I find. For all the minimum and maximum questions, you can do it that way, I think.
Is this question considered difficult? I would say it's I would say it's like medium. You kind of need to know what the question is asking, and there are like a
Yeah.
couple steps to it, but it's not like extremely hard.
So should we get into question 2?
Yeah, we'll get to the rest of the questions after
think,
the next set. Cool.
So an amusement park is planning to build a zipline above a hill on its property. The hill is modeled by this equation. Okay, now after you finish the previous question, clear all the variables. So do that in CAS because you don't want any of the previous equation to be used in this question. Right? And normally if you rely everything on CAS, you might see that, okay, you made a mistake, but then you didn't realize it. So clear everything, and then now you can redefine this to be 3 times x minus 30 squared over 2000. And about this domain, you can define it in your CAS, I think like when you're defining the function, but I wouldn't recommend because a lot of times, at least for my CAS, we're not just solving the questions, like having the domain restriction there, and it's really not really good for like solving derivative and all that. Okay, so I would recommend leave that for specific questions. Where x is the horizontal distance in meters, okay, units, very important, from an origin, and y is the height in meters. Okay. Look at the definition for x and y. They might be different in every question. Above this origin, as shown in the graph below, find dy over dx. Again, something that you just throw into the CAS, and they'll do it for you. So dy over dx equals 9 times x minus 30, x minus 10, 2000.
Yeah, I'll just quickly acknowledge a quick question. Someone asked whether you can start a new document. The problem with that is because we've already defined f of x, right? If you start a new document, then I'm pretty sure it's still defined. But what you can do, I don't know if Yichen used it, is you can start a new problem. I think it's like menu 4.1, and then all the variables are cleared, but you still have everything. It's like a new folder, kind of.
Well, menu 4.1 is derivative.
No, not menu 4. Like, you can just start a new problem on CAS. I'll try and search up how to do it. But yeah, give me a second.
But yeah, like what I did is I cleared everything and I went on to just define new things. Yeah, all right. So for question B, Darren, do you want to scroll down a bit?
Oh yeah, sure.
So just to cover all of question B. Okay, now this is the question where I made mistakes when I did it as a practice exam. State a set of values for which the gradient of the hill is strictly decreasing. Now, what I thought it's just, this is 10, right? Because quite obvious to see that if you make derivative equal to 0, then, and you want decreasing, so it's 10 to 30. But then I was not, what the question was looking for, it was looking for state the values for which the gradient is strictly decreasing. So really, you need to plot out the gradient curve, dy over dx, and also notice the domain. So it will look something like this. And this is 10, this is 30, okay? And for quadratic graphs, we know that the turning point is going to happen in the middle, so at 20. Okay, maybe the scaling is not the best, but so if you want the gradient of the hill to be decreasing, then of course it's 0 to 20. And about whether you can include 0 in the point, I think it's debatable because I think in method they teach you that endpoints are not differentiable, right? And therefore, you can say that it's not really included in the derivative function. Okay, so this is something to look at. So really make sure that you read the question. Here it's asking for the gradient of the hill, not just the height. If it's asking for the height, then it will be 10 to 30. Okay, and here it's asking for the gradient. So draw it out and you can see the question.
Yeah, from what I remember of this question, because I sat this exam, in case you guys didn't know, is that a lot of people got this wrong, this gradient question. Like, so I got it wrong. A lot of smart kids got it wrong. Yeah.
But nevertheless, I think if you make, it's just a 1 mark question. So if you lost a mark on there, I don't think you should be too worried.
Yeah.
Okay, make sure you got other things right. The cable for the zip line is connected to a pole at the origin at a height of 10 meters. And it's straight for, okay. So here we have a linear line where A is between 10 to 20. The straight section joins the curved section at this point, AB. The cable is then exactly 3 meters vertically above the hill from x between A to 30, as shown in the graph below. So this cable is really just part of the hill and then shift the entire curve up by 3 units. Say the rule in terms of x for the height of the cable above the horizontal axis for x between A to 30. So basically we want to say the equation for this, for this. And maybe you can define it as height of x. Like I said, it's really just shifting everything up by 3 units. So you have the original equation. I think it was 2000, yeah. And then plus 3. I like to say the domain. Okay, so there you go.
Wait, Yichen, I think it's
yeah.
doc 4-1. I don't have my CAS on me. Can you try it? Doc and then 4-1.
Doc. Oh, yeah. It's,
so like all the variables are cleared, but you can still check your like past calculations if you wanted to. I think that's, yeah.
Yeah, I think it is. Yeah, it is. So doc 4-1. And then, yeah, if you, the previously defined functions are not defined in the new problem, it like creates up a new window for it. Yeah, you can use that then. It's very good to use. Okay, so find the values of x for which the gradient of the cable is equal to the average gradient of the hill for this. Okay, so when you're thinking about average gradient, or just average something, average rate of change, then it will be FB minus FA over B minus A. And find the value of x. Okay, so in this case, the average gradient of the hill in this interval will just be, hold on, yeah, F30 minus F10 over 30 minus 10. Okay, so maybe I should, I will, oh, whoops, what did I do?
No, you just clicked on it. It's fine. Yeah.
Just make sure it's not messed up. All right, so M average equals this, and that you put it into your CAS. I'll do that real quick. And that gives you -3 over 10. All right, and you want the derivative of x for the height function that we defined previously. And also you want to put that h of x that you defined into the CAS. All right, so do a new define h of x, which equals f of x plus 3. And that's something you can do in the CAS as well. Okay, so you got that. And now, okay, I think my previous question is a bit, I'm going to move it down. Yeah. H dash x, we want it to equal 3 over 10. Okay, because we want the gradient of the cable to equal the average gradient, and you put that into the you write it down, and really you can just give it the value. And note that here it says the values of x, so it's a plural here, and normally that implies you will have two values for it. And also make sure you check the domain for each of it and see if it's between 10 to 30. If it's outside the domain, then you need to skip it. The first one I found is 20 minus 10 root 3 over 3. And as you can see, if you do it manually, like writing the equation all out, then it would be very hard, right, and difficult. But with the good thing about exam 2 is good use of CAS, and just write down this much. Write down all you need. Like write down the average gradient, the gradient, like the method here, gradient of the cable equals this value, the average gradient, and then write down the answer. That's all that they require. And also be mindful that sometimes they ask for the coordinate of points in the cable rather than just the values of x. Okay, so if question asks for coordinate, remember to put it right in the form x f of x. Okay, make sure you calculate the y value as well. All right, but for this question, the just writing out x1, x2 will be very enough. Okay.
Cool.
Do you want to keep going or answer some
we'll probably answer some
questions?
questions. It'll pile up a lot.
I think you are a bit laggy, but
Okay. Yeah.
do you say you want to answer questions or?
Yeah, we'll answer a couple questions because otherwise we'll pile up a lot. Okay, I think Samurai Gorilla was the earliest one that we didn't answer. Do you recommend to frequently sketch out questions?
Frequently sketch. You mean like sketch the graphs?
Yeah, I think that's what he means.
Not too frequently, but maybe like if there's an equation here and then sketch it out. If it's like sort of the main function, for example, in exam, the question 1, it's just that question, right? It's just that function, and you use it throughout the entire question 1. Then maybe I would recommend you sketch it out. But if you do it for every, for example, derivative, then it's probably not necessary. Okay, because the process of putting into CAS and sketch it out, it's not. It takes a bit of time as well.
Overseas scholarship. I think they give a lot of money to you, overseas unis. It's hard to get in, but like I'm pretty sure they endorse you with a lot of money for some reason. I don't know why. It's just what I've heard. Tutors. For Latin, I had this guy called Hamish. For Spec, I had Derek Ha. And I don't think... Oh, and like Chinese, I went to Chinese school. Yeah, and I had an awesome teacher there. Did I have any other? Oh,
Yeah,
methods, I had a tutor as well in year 11. A teacher.
They're mainly questions for you, Dan. So do you want me to... How about you type in the answer and while I'll keep going with the question.
Oh, there's a question for you.
How does that?
What SAC scores did Yichen get for methods special physics?
SAC score? I think I full mark method, right? Or I lost my mark. I forgot. Oh yeah, in 2020 there was this 1 mark. I don't think it's a reasonable deduction, but yeah, I lost 1 mark, and I didn't know my rank eventually. I thought it was number 1, but ended up this year 11 kid got the ducks. But anyways, yeah. And for Spec, I think I was just behind Gordon. I lost. I forgot how many marks I lost. Kind of focused on ranking more than marks.
Yeah. Sure, I'll just type in chat then.
Yeah. All right. So let's have a look at question E. So the gradient of the straight and curved section of the cable approach the same value at x equals a. So there's a continuous and smooth join at a. So remember, these two words basically implies differentiability. And since we know that, whereas in the previous question, the gradient would just be the gradient or the gradient of the tangent at x equals a. So the gradient for the cable at a would be the same of that, right? So that would be gradient equals, what's the derivative function again? Okay, so 9 times a minus 10, a minus 30 over 2000. So just to check again, that's the gradient of the hill at x equals to a. And because we know that for the cable, it's just moving it up, shifting up by 3 units, right? So the gradient wouldn't change. And the gradient of the cable, since it would be the straight section, it would be the same, or there should be a smooth connection. So we want the gradient to match up. So question 2, well, it's 3 more questions, so it's quite a lot. Find the coordinates of A with each value. Again, so now we're looking at the coordinates. So make sure we have both the x and the y value. So first of all, we want to state, I'll say the value or the function of h here. It's 3x, x minus 30 squared, 2000 plus 3. Okay, and so this is at 10, 0, 10. So Darren, do you want to make it come back to the previous
Sure.
section a bit? Yeah, just making some quick labelings on the previous graph. So, and this is a, that's the equation. 3a, a minus 30 squared, 2000 plus 3. Okay. And therefore, the gradient of here will be, it's kind of hard to write down, but 3a, a minus 30 squared over 2000 plus 3. So this is the y value minus 10 over a minus 0. Okay. And we want the gradient to match up, right? So that will equal 9, a minus 10, a minus 30 over 2000. Again, you leave it for CAS. Okay, so solve. All right, and the test gives you a couple of different values. A1 equals negative 7.85. And notice, so for now, I would recommend you write down a bit more sig figs, but then make sure you come back, you convert it to 2 decimal places in the end. 78514. A2 equals 11.6.7356. And it's really important you get rid of the ones that you don't want, right? And we know that A has a domain between 10 to 20. Okay, so note in question, the start of question C. So these two values we can cross out. So we are now left with the second one, 11.1157, and we sub that into the function for h. Plus, that will give me 8.9461. And in the end, you write down the coordinate, which is 11.128.95. Okay, so the reason that I don't round to the end is because, well, if you round it too early, then the value for y might be a little bit off. And this question is not very easy. I just re-explained what I did in the first step. I write down this height function, and from the top of the page, we know that we want point A to have a smooth and continuous connection. So we require the y value to be the same and also the gradient. The left hand side is is how I calculated. Left hand side is how I calculate the gradient for the straight line section. That's the gradient for the straight line. And this is the gradient at A. Okay, calculated using the height function. All right, and we notice that there's only one variable here, so we can solve. Okay, put it into your cast, and it'll do it for us. Okay. So the last question: find the value of the gradient at it. Right, it's not too hard. I think you just sub it in because we've got two functions of finding it, at the left hand side and the right hand side. So I'll just put it in 11 point. Over 2000. No, this will be negative 0.1. Note that there's one decimal place. Okay, so that's definitely a pretty hard question in my opinion. And yeah, so question E2, I'll say is probably the hardest in the entire question 2. Okay, so 3 marks. Maybe you can have a look back in a question and to see if you really understand what's going on here. All right, so that's the end of question 2. Darren, do you think I should start 3 or?
There are a couple questions for you. I'll direct them to you so like you know which ones are relevant. The first one is, what is it? I saw her name. Oh yeah. What advice would you give someone who was in year 11 doing year 12 maths? How do you study effectively for exams other than practice? So Isabella.
I think you did a lot of, like 2 year 12 subjects in year 11. Right? So doing year 12 subjects in year 11, I think it's not, it's very hard because you're competing with people who are 1 year older than you. But at the same time, I think I would say to myself, okay, if I do this subject this year, I don't have to do it next year. Okay, or at least I have more experience than those who didn't do a 3-4 back in year 11. So that sort of makes me feel a bit more relaxed, I guess. But definitely, I don't think I should be the one who answer this question because I didn't do that well in Chinese in year 11. So, but Darren, do you have any comments on that?
Okay, I guess particularly for maths, it's really easy to spend too much time just like smashing out questions, especially in year 11 where you have like unlimited time because you only have like 1 or 2 or 3 fours. So I would suggest you to just make sure you learn from everything. Don't feel like just because you did like 200 billion questions that you're improving, because you're probably making the same mistakes and not really focusing on what's important.
Yeah. All right, Darren, is it any other questions?
Yeah. How do you study for exams other than practice? I guess maths exams in particular.
Other than practice, I think rather than just, I don't really think I did other major things for math other than just practice exams. But the main thing I would say is that math is really sort of accumulative. You want to build up your knowledge throughout the year, not just think about, okay, if you do 20 exams but in the end of the year and then you get 40 plus or 45 plus. So it's really important that throughout the year, if you have any loopholes in your knowledge, okay, of your material that you study, make sure you like fill it, right? Don't leave it to the end of the year, because by then you really can't do the exam if you have any I know knowledge loopholes. I think exam preparation or like writing practice exams are really for, what do you call it? To check if there's anything that you're not really confident with. But you should really do the exam or do the practice, knowing that okay, I'm confident in the material and I'm just checking. Okay, so yeah, I would say focus on the knowledge that you accumulated throughout the year, yeah, rather than focusing too much on how many exams and how we prepare for exams.
One more question, then we can move on. Two more.
All right.
Okay. One is, how much did you rely on your note sheet, and what did you fill it with? So your bound reference.
Oh, okay. So what I brought in, I put the textbook in and my notebook. But honestly, I don't think I used it. I probably used it once or twice. But nevertheless, I would recommend you like print it in, right? Because it sort of at least it makes me a bit more confident in doing the exam, knowing that okay, if there is anything that just if that I sort of missed out, then I have the textbook there to check. Okay, and I know where every chapter is, where every content, where like derivative is, where integration is. I can come back and check it real quick. But mainly it's just making me feel confident, I think.
And last question, were your exam scores on company papers like Kilbaha and ITU lower than, say, like MAV and VCAR?
Like definitely, I didn't do much because I heard from a lot of my peers that the Kilbaha is not the best exam, right? It's not very good. So I didn't. I think I did like one or two Kilbaha exams, but the main exams I did are VCAR ones and the I think it's Heffernan. Yeah, I heard it's a pretty good exam paper, and some of them. But yeah, like the harder exam papers, I generally get less. Like normally, I would probably lose more than 10 marks in Kilbaha and math. Okay, VCAR is normally like less than 5, I would say.
Yeah, I agree with that. I didn't really care about my exam marks on like those exams, and oftentimes I wouldn't do them under time conditions as well. The ones I would prioritize time conditions are like VCAR and
Yeah.
Heffernan and NEEP a bit as well.
Can you say this one last question for me?
I think it was just those two.
All right.
Oh, it was a quick one. Did you print them out or do them online? I printed them out. What about you?
Oh, I printed them out as well. But I have a friend. Yeah, I did the exam with him. Like, and then we mark each other's paper. He did it on the tablet, so he did it on an iPad. So I think that worked for him. It really doesn't.
Jim?
I don't think it matters that much.
Is it Jim?
It was Jim. Yeah.
I would say just do it on paper. Like, I guess it costs a little bit of money, but it's like the actual exams on paper. So like,
Yeah.
simulation. Yeah.
Oh, I just add one more comment. Like before the exam, I was doing exam papers with Jim like literally every day. We would go to the school, and we don't have class, right? So we go to like a study room, and then we do print out papers for me, and then we do it. Spend like 2-3 hours. That time was pretty chill for me because, like, if you walk into school and then you know that you don't have to attend any classes, I just didn't make me too stressed in the end of when I actually sit the exam. So maybe that's something that you can do as well. So rather than just staying at home like doing 2 million papers, like go out and see your friends, maybe like have a study session with them. This probably will help you ease down the stress a little. All right, so do you want to have a look at question 3?
Yeah, I'm on question 3 at the moment.
Okay, so during a telephone call, a phone uses a dual tone frequency electrical signal to communicate with the telephone exchange. The strength F of a simple dual tone frequency signal is given by this function. So 2 signs, again, something that we can't really draw, but luckily they give the graph, where t is a measure of time and t is greater than or equal to 0. So again, note our domain here. part of the graph of y equals f of t is shown below. State the period of the function. Okay, so when you have two or more circular functions, you want the period to be the lowest common multiple of the two. Okay, or you can really kind of see it that the period is 12. Right? See it from the graph. But if you don't have the curve, it will be. I'll just write it in red. Sine pi t over 3, it's gonna have a period of 6, and sine pi t over 6, it's gonna have a period of 2 pi over pi over 6, so 12. So the lowest common multiple of them is 12. Okay, and that will be the period of the function. Find the values of t for where f of t equals 0 for the interval t is an element between 0 to 6. I'm gonna just write down the value here because I think it's not hard to put it in. But there's a couple of things to note out. Because it's a sine function here, if you just make it ft equal to 0 and then solve, at least for my case, this is the syntax. And also note that it's not x here, it's t. So what the cast is going to give you is like a whole bunch of different values, right? Because there are really infinitely many solutions to this question. And I would recommend that make sure, like this is not really a recommendation, but make sure that you have the domain 0, x is between 0 and 6. And one more thing, here, this is close bracket, right? So 0 and 6 should be included. If you put 0, x is greater than 0 but less than 6 like that, that's gonna not give you the two solutions at the two ends. Okay, so that's not good. And also you can tell from the graph. Okay, so 0, 4, 6. All right, but the first two questions of every of this extended response questions should be quite easy, I would say. All right. Darren, do you want to move on?
Yeah, cool.
So find the maximum strength of the dual tone frequency signal correct to 2 decimal places. Now here, you might assume that the maximum strength happens at t equals 2, and it might. I'm not 100% sure, but it's good. I think you need to check where the local maximum is. So what I would do is, I don't necessarily write this down, but f dash x equals to 0, and I'll set the domain to be between 0 and 0 and 4, sorry. Because I know that the local maximum will happen in this range, okay? And anything outside this range, I can basically just ignore. And I think I haven't defined my equation yet. Sine pi times
I think you used t, but it's not a big deal.
Did I write? Oh, yeah. No, I think, yeah, I should change it to t. 6.
Oh, whoops, I'm covering it. My head's covering.
Okay, so, whoa, it turns out it's actually not, it's actually not 2, it's a bit less. And it is t equals 1.787. And if I put that in, yeah, so f max equals 2 decimal place, so 76. So this comes from f 1.787, and make sure you don't put the 1.79. That's a very, very common mistake. We're looking for the actual maximum value, not the value of x or where the maximum occurs. Right. And yeah, so here's a it's very easy trap that you can fall in. So the graph may tell you that the maximum occurs at t equals 2, but the reality is it occurs before that, 1.76. Okay, so make sure you always do the check where the local maximum happens by doing a derivative. Okay, and it doesn't take that long, right, to put into your cast. And yeah, it could be a really easy mark.
Yeah.
Saved.
One thing I'd say with question C is to check your answer. I'm pretty sure there's a thing in CAS where you can just draw the graph and then you like click like menu graph maximum and like highlight that area and it sort of gives you the answer as well. So you can sort of compare those and see if you get the same.
Yeah, I like, to be honest, I don't particularly like that because it's not like the graph system on CAS is not the best. It's quite laggy for me, and sometimes it doesn't give you the required decimal places. For example, if it requires 4, it might only give you 2 or 3. Okay, and then eventually you gotta come back to the calculator mode.
So it'd be like a check, but I wouldn't do it first.
Yeah. But as a check, I think that's very useful too. Find the area between the graph of f and the horizontal axis for t between 0 and 6. Do you want to come back to the previous page, Darren? Yeah, like you have this graph, it's very reliable, right? And if we want to find the area, remember we cannot. So area is not 0 to 6. What is it? F of t, right? F of t dt. Okay, this calculates the net signed area. So we can't just, look at the area question and then we immediately say, 0 to 6, and then through the functioning dt or dx, and then that's the area. No, that's the net signed area. So basically what that means is this part will be dealt with as a negative area. And so one way we can do it is area. Should I write it in the next page or?
Write it here.
Darren, come back to the next page.
Sure.
So question D. So yeah, one way is to split it 0 to, I think it's 4 ft dt. Okay. Plus negative 4 to 6. I think it's negative here, right? Yeah. Ft dt. So the reason I write plus bracket negative here is because, well, I don't want, when I come back and check, I want to see that, okay, I'm doing 2 areas added up together, not one area minus another area. I know the calculation's the same, but I think intuitively that's probably better for your understanding. And that, again, you can do it in your CAD really quick. 4 to 6. And if you add this up, 15 over pi unit square. Another thing that sometimes might not work is the modulus function way. So 0 to 6 modulus f of t dt. That can give you the area as well. But sometimes the problem with that is might not give exact value. Okay, or it also might not might be false. Okay, so CAS cannot handle the situation. So CAS cannot handle it. But in this case, I will try if it works. Modulus f of t dt. Okay, so yeah, here it gives you, what my CAS gives me is A equals 4.77, right? And it's looking for exact value. So I guess that's not, you cannot really write this down, but nevertheless, you can use this as check. All right. So here, question E, this one is a hard one. let G be the function obtained by applying this transformation to the function f, where A, B, C, and D are real numbers. Find the values of A, B, C, D, given that, so here, the addition of two integrals has the same area calculated in part D. All right, Darren, do you want to come back to the...
Sure.
Just clear things up a bit. So basically in D, we found the area. We found this area. Okay, and now the new equation they give is, let me just write it down somewhere. I have a lot of different, I'll clear it up a bit. Otherwise it's going to be very messy. Yeah, I think that's enough. So So the integral that I give is 2 to 0 gt dt plus 2 to 6 gt dt. And okay, maybe we can change this up a bit. So what we see here is that the first integral will be negative. This one will be a negative integral. And so maybe we'll think, okay, so the new transformed curve will look something like this. Okay, this part is negative. So that's why we add the negative sign in the front to make it a positive. Well, and from 2 to 6 gt dt, we know that part is positive, right? So it may look something like this. All right, that's not the best curve. I'll have another attempt. It doesn't even pass through the two. Yeah. All right. Okay. And it's maybe a bit confusing how to get the original curve to that curve. So from now, at this point, what I'll be thinking of, we do it step by step. Okay. So if we have a look, maybe we can flip the original curve to this. Okay, so the original curve goes like this. It's here, and then I'm just flipping it with respect to the t-axis, so the horizontal axis. All right, and then what I need to do is I need to translate it to the left by 6 units. Okay, but be really careful here. Apart from 6 units, can we also translate it by other numbers? For example, 12 units, 18 units. Can we do that? Okay. In fact, this one, so the curve here, okay, that's also a possibility. And that would need to be translated back 18 units. And that makes sense, right? Because this one is differs to this one by 12 units, and that's the period of the function. It's all a bit messy here, but all we want to do here is 2 transformations. The first one is reflection in the t-axis, and second, translation. Okay, 6 units to the left, plus other possible values. Okay, by other possible values, I'm just saying, well, 1 period ahead. Okay, entire period to the left. All right, so if you want to have a look at the actual value of A, B, C, and D, well, A here, be very careful here, A here controls X. And what this do is it reflects in the Y-axis. Okay, but we don't want to do that. We want to reflect in the t-axis, so that must be 1. And B here has to be -1. Think about it, right? Like if you reflect it in the t-axis, all the originally positive y values now becomes negative, and all the negative becomes positive. Okay, so B has to be reflected. and get out the easy ones first. We don't want any vertical translations. So D here will be 0. Now it's the question for C. C, we know that, well, if you translate it to the left by 6 units, that would work, right? So -6 would definitely work. Okay, but apart from that, we can also translate it to the left by 6 plus 12 plus 12 plus 12, okay? Or 6 minus 12 minus 12 minus 12. So that would be -6 plus, hold on, does it set a restriction on? Okay, so here is the thing, right? I think I missed out on this point before. You can't really translate it you can't really translate the curve to the right, because, Darren, if you flip to the
I'm on the
previous page. Yeah, like the curve.
Yeah, I'm on the curve page.
Yeah, there isn't anything to the left of the curve, right? So t less than 0, the curve doesn't exist. So all we can do is shift it to the left. We cannot shift it to the right. Right. So let's come back. We must shift it to the left, and that means it's -6 or -6 minus 12 minus 12 minus 12, and so on and so forth. That will be minus 12k, and k here must be a positive integer or 0. Okay, so this is not easy. Definitely not easy. I think it was from memory one of the hardest questions in this exam.
If you don't get this, because there's a lot of thinking involved. Like if you don't get it and you're not aiming for like a 45 plus, just read it and skip it. Like guess some numbers and then
just two marks, right? Like the entire paper has 120 marks, including exam 1 in total. So I think make sure you get the marks that you can get first, and then come back and think about it. So question F, the rectangle bounded by the line y equals k. So k is a positive real number. The horizontal axis and the line x equal to 0 and x equals 12 has the same area as the area between the graph of F and the horizontal axis for one period of the duotone frequency signal. All right, so now we want to find, first of all, it's very bit confusing, right? And if you know about average values, then it might hint you towards that path. Okay, you find the average or the net sign value between 0 to 12. But this is actually, you'll see that this is symmetrical, right? So if you find if you integrate from 0 to 12 ft dt, that's going to give you 0 because all the errors kind of cancel out. And well, that doesn't mean that k is 0 in this case, because we're really looking for the real area, not the net sign area. So the area between x equal to 0 and x equals 12 will be the area that we found previously times 2, which is 30 divided by pi. Okay. So in question D, we found the area from t equals 0 to t equals 6. Not net sign, but the actual area. And we need to multiply it by 2 to account for the 6 to 8 and 8 to 12 area. And now all we need to do is, so 12 times k. So this rectangle will have the same area, right? So this equals 30 over pi. And then all we need to do is rearrange. So that will be 5 over 2 pi, I think. Yeah.
Cool. Yeah. We have a couple questions. First one, someone asked you whether you got a 99.95, and also, do you want to sort of go through your study scores?
Oh, okay. So yeah, I did got a 99.95, and My so I got 50 for method and physics. I did EAL, which I got 46, and also specialist math, which I got 47. And my bottom two is Chinese and Chem. I got 40 for Chem and 38 for Chinese. That's my raw study score. And my final aggregate was 210.6, I think. Yeah.
All right, I'll just
So
answer.
just at the line.
Yeah. I'll just answer a couple questions verbally. What are you doing in uni? I'm doing med. Other than VCAR for Chem, I don't do you remember the company for Chem? There was like one. I don't
Neep?
remember the name.
Neep?
Neep. There's like another one that like doesn't do exams for other subjects. It was only Chem.
Really?
Like the black one.
I can't remember.
Okay.
Like, I'm not gonna lie, right? But I kind of only did like three papers for Chem, and they're all VCAT. I didn't do much. I didn't put much attention into Chem
Yeah.
because I know that it's not gonna be my top four. And
This doesn't really help with further because the content's different. Andy, is Melbourne Uni Med bad? Melbourne Uni Med is different in the fact that you have to do 3 years beforehand. You have to sit the GAMSAT if you didn't get 99.9 or 99.95. And it is very hard and you have to study and it's really competitive. So it is pretty tough. And there are a couple comments for you, Yichen, if you want to have a look.
they want me to make a YouTube channel.
Yeah.
Maybe in the future when I have time, and I'll maybe get someone to edit my video as well. In the future, yeah, if that might be possible.
I think Yichen's very good at explaining things well, which is really nice and helpful for you guys.
Hopefully, if you want, I can come back. Yeah, and maybe to clear out some questions.
Yeah, that'd be awesome. Thank you.
Uh,
I'll just answer the
so
last one.
yeah. So now, do I keep going?
Oh, I'll just answer one question, just the last one. Are the students at Monash Med who got into undergrad mostly private school kids? Not really. Like, quite a few are private school, but also a lot are selective entry schools, like Melbourne High. Actually, I don't know any McRob people in Med. Maybe I just haven't met them. But yeah, Suzanne Corey and what do you call it? John Monash as well.
Oh, I can talk about physics.
Oh yeah. You've got questions for that. Cool.
For physics, actually no. Okay, checkpoints is very helpful for Chem. And physics, I didn't do much questions on it. It's mainly on just doing practice papers. I think I did like 10 in total. The VCAT one, some of the previous VCAT ones are not really applicable to the new study design, and a bit of staff and NEEP. But for physics, again, I think the most important thing, this is more important than math. Maybe math, you can get like quite a decent score with doing a lot of papers. But for physics, I think the most important thing is definitely understand all the content, right? And know your materials well, not just applying formulas. It's even worse in physics if all you know is applying formulas, because I think 30% of the question is to explain questions, and if you don't know what's going on, then yeah, that 30% of the mark is really hard to get.
Yeah. I definitely now, especially for science subjects, they're kind of moving towards asking you to explain stuff. It used to be a lot of maths, but now they're moving to explain. With Chem, I highly recommend going through the study design. It has all the dot points and all the stuff they'll possibly ask you. Like, I just recommend it so much. It's really useful.
My physics cheat sheet. Well, yeah. But for, what I put in my physics cheat sheet is a lot of the answer to explain questions. I don't have any formulas on it, or I write it manually. But yeah, I think explain is the main thing for physics. So watch out on those. Do you want to go to question 4?
Sure. Yeah, just last thing. Yichen's not studying med. You want to tell me what you're studying?
I do. Oh, I want to do like data science. So it's like computing science, computer science, IT related area. And I'm right now doing a bit of math, physics, and of course computing subjects, and a bit of finance. as my
Finance.
breath.
Oh, okay.
Yeah.
Like Gordon as well.
Yeah.
You guys are like businessmen.
Yeah, we're gonna be that. I'm not gonna say. So question 4. Now, always in exam 2, you're gonna have a probability focused question, and here we are. The Lorentz birdwing is the largest butterfly in town A. The probability density function that describes its lifespan x in weeks is given by. Now, for PDFs, something to note: area under the curve equals 1, and the y value represents frequency, not probability. Shit, I don't have space here. Frequency. All right, and normally you see this. So part of the curve, part of the domain is defined, and everywhere else it's 0. So you might see something like this: f of x, where maybe somewhere here it's defined, but everything else it's like it's 0, sitting on the x-axis, and just making it a bit obvious. So when you draw it, make sure to make this part and this part obvious, right? Otherwise, you might get marks taken off. Okay, this is continuous random variable.
And don't forget to draw it as well. I remember one specific VCAR question that I did, and I forgot to draw it because it's kind of easy to forget. Don't forget to draw it.
Do you find the computer science stuff hard to pick up for somebody who doesn't know how to code? No, I think it's really about your logic ability. Okay. Computer science is not hard to pick up if you are reasonably confident at math. Okay, so the first couple of basic contents are really basically just your reasoning ability and logic. Okay, if you're confident with that, I think computer science shouldn't be too hard at the start. All right, and here maybe I wouldn't define this function for a continuous variable. Would you define it, Darren?
Would I define? No,
Like
I'll
this?
just type it in.
Yeah, because really the domain, like it can vary, right? Sometimes you have also piecewise function, where over different domains you have different functions, and that makes it a bit hard. Find the mean lifespan of the Lorentz birdwing butterfly. Okay, so in probability, this is where the one place you need to memorize some formulas. For continuous random variable, just to recap, okay, continuous random variable, for each point, specific point, the probability is insignificant. So it's basically 0. It always asks for the probability over a certain interval, okay, not a specific point. And yeah, I think I've covered most of the stuff before. Area under it represents probability, and it should sum to 1. And the y value represents frequency, okay, as different to discrete random variable. Find the mean lifespan of the Lorentz. Okay, so this is 0 to 5. Okay, so the formula I'm gonna write down is -infinity to infinity x f of x dx. It's a bit like how you do it in discrete math, right? So a discrete random variable. You have the x, you have the kind of the probability, and then you are summing it up using the integral. Okay, you can think of it as that. And a lot of people, they forget the x in the front, and yeah, something to avoid.
I mean, if you forget the x, you'll probably just get 1, won't you?
Yeah, you would get 1. Oh, maybe here now you will want to convert it to the actual formula. 4x over 625, 5x to the power of 3 minus x to the power of 4 dx. Okay, where's my cast? And if it doesn't ask for, okay, very important, if it doesn't ask for decimal places, leave it as exact value, unless it's not really possible to get the exact value out of it. So this is 10/3. And to get the context, this is the variable in weeks, right? This is the unit, so I will add it in as well. In a sample of 80 Lorentz, so this is about sampling, Lorentz bird with butterflies. How many butterflies are expected to live longer than 2 weeks? Correct to the nearest integer. Okay, so the probability, actually, no, this is not really something, my bad. This is binomial distribution. Or, to be more specific, this is Bernoulli sequence or Bernoulli experiment. Okay, where Bernoulli experiment requires a couple of things. First of all, every outcome results in every experiment trials results in two outcomes, success or fail, and this really depends on how we define them. And every trial is independent of the adjacent trials. Okay, I think there's one more. I can't remember it on top of my head. But yeah, I think also large enough sample. I think like a large enough population proportion, a large enough population. So binomial distribution, firstly, we need to find the probability of X that has, what do you call it? A life greater than 2 weeks. Right? So whether we put greater than 2 or greater than or equal to 2 doesn't really matter, because each point, the probability in continuous random variable doesn't matter. So 2 to 5, okay, be careful here. Don't write this 2 to infinity. Okay, why? Because after 5, the probability or the frequency is 0. So it's impossible to get anything above 5. And you can check, maybe if you do it above 5, you might get an answer that's greater than 1, and we don't want that. 2 to 5. And that would give you, what is it? 4 over 6, 125. I times x to the power 3. This is 28533125. Okay, so now we are really stepping into binomial distribution. So I wouldn't label it x here because x is predefined to be to take on the continuous random variable, and I'll call it something else. For example, 1. So y follows the binomial distribution, or the number of butterflies that have a life greater than 2 weeks. Okay, now we are dealing with discrete data. So we have a n of 80, so the number of trials, number of experiments did. Well, here it's really just 80 butterflies, right? And each has a probability of this we calculated beforehand. Expected, so expected value of y equals np. What do I write? N times p, and that approximately equals 80 times. Okay, so rounded to the nearest integer. Okay, but technically in other questions, if it doesn't ask you to round, even for discrete data, for binomial distribution, you don't need to round, because expected value calculates the long-term average or the weighted average. So decimal should be allowed. So question C, what is the probability that a Lorentz bird-winged butterfly lives for at least 4 weeks? Given that it lives for at least 2 weeks, correct to 4 decimal places. I like how they worded. So what we're looking for is probability that they have a life of greater than at least 4 weeks, given that they lived for at least 2 weeks. So, like this. And then using what we know about conditional probabilities, this would be no. The numerator should really be x is greater than or equal to 4, intersection with x is greater than or equal to 2. But in this case, or in a lot of the different cases, the first probability is just a subset of the second. So we can write this. Okay, because if it's greater than 4, then obviously it's going to be greater than, greater than 2. But sometimes it may not be the case. Okay, you actually need the intersection symbol there. So I would recommend you to be very careful, or write down the intersection and the stuff for everyone, and then deduce if you can remove one of it. We found the denominator before, but we haven't found the numerator. And so this will be 4 to 5 f of x dx over 2 to 5 f of x dx. And this is, okay, maybe it's good to define it beforehand. So this is, again, correct to 4 decimal places. Right, 8212853, and it approximately equals 0.2878. But the first couple of questions should be pretty standard. I think the main thing for probability is that, is basically understanding the question. Okay, what is it asking, and coming up with a method to do it. Whether it's discrete, is it random, or do we use binomial? Do we use normal distribution? Okay, once you have a way or a method in your head of solving it, then the actual computation should be pretty easy. All right.
Cool. There were a couple questions. Let me find it. I'll just answer this one quickly. For someone who's terrible at writing or anything related to English, but extremely good at maths, would you recommend taking Ing Lang rather than English? I think that's the reason a lot of people do take Ing Lang. So I think it's a decent reason. Especially in English, you got to analyze a lot. But Ing Lang, you got to be analytical as well, but it's sort of different. You analyze language and words, whereas in English, you're analyzing a lot of things like big humanity, like war, death, loss.
Yeah, like ideas, values.
Yeah.
Stuff like that. So, for English, I think, I don't know what Ing Lang is like, but English I heard is pretty, like, you need to be able to think a lot about the text and the movie or whatever. So thinking ability, like whether you can come up with a lot of very deep like values, and that would you like to analyze films, I think stuff like that. For Ing Lang, is it like more technical, I guess?
Yeah. So you analyze how language contributes to like how formal a piece is. You don't really analyze ideas and humanity.
So yeah, I did EL. So EL, I guess in a way it's pretty similar to English, but the people that we compete against is different. If you like to think about ideas, a lot of different ideas, like what Darren said, like humanity, and what I did was like kind of like war, cruelty, and resilience, stuff like that. You want to think about the values. You like to think about it a lot, then I'll recommend English. It's probably a better one.
Someone asked, is that something both of you would suggest? Rather than studying hard for all, put one subject on the back burner for bottom 2. I don't have a clear subject that would be bottom 2, but should I do that anyway?
I think it depends on case to case. So for me, well, my Chinese has a scaling of 46, I think. And I think that's a pretty secure place for number 5, right? If any of my subjects actually drop below 46, I can use that as a backup. Well, Chem, for me, I know that I really don't, it's not gonna be my top 4. It's not gonna outscore my math or physics. Okay, so that's why I kind of given up on chem, but I don't think that's probably the best advice I should give here. Yeah. So Darren, what do you think about that?
I think that since you don't have a clear subject, definitely put in effort with all your subjects. Because I had 6 subjects in year 12. You probably have 5. But like I've heard a lot of stories of people who, especially when the subjects were really close, have like unexpected subjects suddenly do well and pop into their top 4. When all your subjects don't really scale and when all of them are pretty close, definitely put in effort with all of them and sort of see which one comes out on top. For me, I was similar to Yichen. Like my chem, even if I got a 50, it wouldn't have been in my top 4 because all my subjects scaled a lot. And the only subject that didn't really scale was English, and that has to be in your top 4. So I knew chem was for sure towards the bottom. But even then, I put in a lot of effort into it until like really late in the year.
There's a couple of questions here I want to answer. First of all, I do go to Melbourne Uni, and okay, so the binomial notation, why that tilde by binomial, AT, and the fraction for probability of success for each trial. That's you have to put that in. Okay, and sometimes people also put in, oh, this is what my teacher told me, like what does y represent? Okay, maybe, but that's not required. But nevertheless, it makes it a bit easier to understand, right? So y is the number of the discrete random variable of number of butterflies that have an expected, or no, that have a life longer than 2 weeks. Okay, but sometimes it can be really hard to spot. If you write down the wrong thing, I don't want to guarantee that they won't take the mark off. So can we just skip the intersection part? In this case, we can, because, well, x greater than or equal to 4 is a subset of x is greater than or equal to 2. But in other cases, I'm saying it might not be a subset. Okay, in that case, you cannot get rid of the intersection. How did Scotch tennis go?
Yeah,
Where's Tom here?
Tom Patton. Do you know who he is?
Nah.
No, he's in field. He's like first seed tennis since like year 10. First.
Oh really?
Yeah.
Isn't it Max Potter?
No, Max second.
Okay.
Okay, I just answered. How can you improve in Lang? It's a sort of a broad question. Like there are different sections of English. I definitely work on each section separately. And for short answer, memorize the meta language. For ACs, develop a structure and techniques you can rely on. For essays, make sure your paragraphs are really good and adapt to topic. That's like the short answer.
All right. For tips of going back through your work in a maths exam to check for mistakes and etc. Because yeah. So like when I do practice exams, I find it really. I was lazy as well. I don't want to come back and check it. But for exams, like for the final exam, of course, everyone would come back and check it. But I sort of do checking in 2 ways. So after I do a question, if I'm not 100% certain, I'll check it real quick. I do the computation or try to do it in another method, but I wouldn't spend too much time on it because there is really a potential that you don't get to the final bit. So that's why time management is really important. And after I finish everything, I'll like circle questions that I think worth checking. Okay, circle it and then come back. That's your first priority. Check that first. And then after that, if you still have time, check the other bits. Okay, but for checking, find another method or do the computational, all the working out in a different way if you can. Okay, so maybe if you can use second derivative here comparing to a gradient table, or I can't really think of an example here. But yeah, try to have like this different method. My final score, scale score or aggregate. For method and physics, it's 50. So physics is 50 and method is a bit above 50, like 50.4. EL, it's like 46, a bit more than 46 as well. Special is like a 54. Chem 43. I don't know. Chinese are 46, all scaled. Do you need to know a specific way to write a domain? Normally, as long as it's notationally correct, then it's fine. Okay, there's no specific way, but I would recommend sticking to one way of writing the domain, because this is one of the things where you can, if you do different ways, like it's, I don't know, just choose one that you're most comfortable with and stick with that. I do algorithmics not in high school.
All right. With AS, my final scaled scores were 50 for English, 53 for Spech, 54 for Latin. What was my fourth? Chinese 51, I think. Yeah. Methods like 49 and Chem 46 or 47 probably. And what was my seventh? No, I think that's covered. I feel like I'm missing a subject. My bottom two was methods and
Latin, did you mention them?
yeah. But what was my bottom two? Chem was my seventh. Methods was my fifth.
Oh, inline.
Oh yeah. Inglang. Inglang was like 49 point like something. 0.5.
Yeah, 49 is the bottom two. Better remember your scores there. All right, so do you want to keep going?
Oh yeah.
We
I
are
just answered
at
this last one.
question D. Oh yeah, so
Okay.
the wingspan of Lorentz bird-wing butterflies in town A are normally distributed. Okay, so this is like a completely different question. Right, normal distribution, it's a special type of continuous random variable that it follows a certain function, and I think it's like 1 with square root of 2 pi times the standard deviation e to the power of something. Can't remember on top of my head. The mean of this and the standard deviation of this, not the unit. Find the probability that a randomly selected Lorentz bird-wing butterfly in town A has a wingspan between 16 and 18 centimeters. So again, like binomial distribution, which is a sort of a special section of discrete random variable, here the normal distribution is like a special set of continuous random variable. Again, you need to define it. Wingspan follows normal distribution, and then you'll be writing. Sorry, you're done. Can you hear me?
Yeah.
All right. Normal distribution, and the things we need to write is the mean and the standard deviation. Okay. Remember to have it squared here. What my tutor told me is you can write the variance in this, but what it really you should be writing is standard deviation squared.
Yeah. Standard deviation is also more useful usually. So writing it as squared is better.
Yeah. W is between 16 to 18. Again, because it's a continuous random variable, having it as less than or equal to or greater than or equal to doesn't matter. And that's, you put it into your CAS and remember the 4 decimal place. Normal CDF 16 to 18. And because it's quite outside the mean, right? The mean is 14.1. And you might think of it as something like this. So this is 14.1 and 16, 18 somewhere here. So it's probably going to be pretty small. And the answer is like that, 1512. Okay, make sure you do the rounding. Question E. Lorentz bird-wing butterfly is considered to be very small if its wingspan is in the smallest 5% of all the Lorentz bird-wing butterflies in town A. Find the greatest possible wingspan in centimeters for a very small Lorentz bird-wing butterfly in town A, correct to 1 decimal place. So this is where you can use inverse normal.
Yeah.
So the area is 0.05. Now, be very careful here. When you tell the CAS, at least for this one I'm using, the area that it counts is always starting from the left-hand side. And so it starts counting area like that. So if you want to find this 5%, you have to basically find the 95% of this. Okay, I'm not sure. Hopefully that makes sense. Okay, so but since we're finding the smallest 5%, right? So we can just write probability of W less than a certain value. Let's call it small, I don't know, equals 0.05. And you put that into inverse normal, 14.1, 2.1. And that's going to give you S equals, or really, X max 10.6, 1 decimal place, and with the unit. Units are not necessarily essential, but I like to have it in.
Yeah.
All right. So each year, a detailed study is conducted on a random sample of 36 Lorentz bird-wing butterflies in town A. Lorentz, I literally hate saying this word over and over again. It's considered to be very large if its wingspan is greater than 7.5. Okay, so we don't have to calculate that number. It's given to us. The probability that a wingspan of any Lorentz bird-wing butterfly in town is greater than 17.5 centimeter is 0.05 to 7. That's probably a number you get from using the normal distribution. Correct to 4 decimal places. Find the probability that 3 or more of the butterflies in a random sample of this are very large. So again, this you might think this is normal distribution, but okay, so this is actually binomial, right? Because we have a sample size of 36, and each of the 36 is either very large or not very large. Okay, so it's discrete. We can't have 0.5 of Lorentz butterfly being very large and the other 0.5 being not. So again, define another binomial distribution.
Someone's been asking, if you do like LWB, do you have to define what they are? In terms of like,
Sorry?
Like you know how you do the letters, like L or like W for wing size. Do you have to say what they are or what they represent?
I don't think you have to. Just any letter will be fine. Or maybe, okay. But some teacher, like in some school, they might have specific requirements for sex. So they might ask you to write, okay, define what L is for, what W is, what this is. And they can take marks off in sex, but they won't in final exam.
Yeah.
Okay, that's what I'll say for it. 36, and the probability is 0.0527. But you can see, you can see that it's not really. They only give you 2 lines for 1 mark question, so they wouldn't expect you to write too much. So you don't have to write like a lot of equations and so that for this. Just stating it and then writing the probability would be good enough. So probability of L, what is it asked for? 3 or more. Now for binomial distribution, whether it's greater than or equal to or greater than, it will make a very significant difference. And this equals 0.2947. All right, question 2. The probability that N or more butterflies in a random sample of 36 Lorentz bird-wing butterflies from town A are very large is less than 1%. Random sample. Find the smallest value of N where N is an integer. So the way I do this question is by trial and error. So you try a couple of different values. Okay. So basically, so the question is asking, out of the 36 butterflies, all right, how can I choose my least number of butterfly wings such that all the number above it or equal to it will have a percentage less than 0.1, percentage of 1%. having very large wings. All right. So what I write is so basically now what I'll be doing is, okay, I go to binomial distribution and I test the different numbers. For example, 36 is my number of trials, right? And probability of success is 0.0527. And then I'll set my lower bound, upper bound to 36, and I'll constantly change my lower bounds. So for example, something like 10, 15, 5, 6, and I see which probability is going to give me just below 0.01. And the value I found is when n equals 6, probability of L greater than or equal to 6 equals 0.01066. So this is still greater than 1, and we don't want that. When n equals 7,
You mean greater than
probability of L
greater than 0.01.
Oh yeah, oops, my bad.
No.
0.01. Probability of L greater than or equal to 7. So basically we're excluding the point n equals 6. That would be 0.0024, and that's less than 0.01. And so by this we show that, okay, when you just go from 6 to 7, your probability would decrease to 0.01. And the value for n here, and smallest would be 7. I think I'll finish these questions and then get to answer some questions.
Cool.
For random for random samples of 36, okay, this is now something an estimation. N or more butterflies in a random sample of 36 Lorentz birdwing butterflies from town A are very large. Oh shit, no, that's question 3, sorry. For this much butterflies in town A, capital P hat is the random variable that represents the proportion of butterflies that are very large. Find the expected value and the standard deviation of P hat, correct to 4 decimal places. Okay, so for what do we call it? Population, expected population, expected sample proportion. This would just be the probability, okay, for each independent trial, and that's 0.0527. And the standard deviation of P hat would be square root P 1 minus P over N. And plug numbers in, 0.0527, 1 minus 0.0527 over 36. That will give me 0.0527. And that's 0.0372. And notice the required decimal place. Okay, and this is really just applying the formulas. So Darren, is this in the formula sheet?
Yeah.
Like for sampling?
I'm fairly sure.
All right, then I guess just looking at that would be fine. What is the probability that a sample proportion of butterflies that are very large lies within 1 standard deviation of 0.0527, correct to 4 decimal places. Okay, so now I want P hat to be between lies within 0.0527 plus 0.0374 and this is less than 0.0527 minus 0.0374. If you think about it, it's really like you have a normal distribution here. You have the mean here, expected value of p, and then this is minus 1 standard deviation and plus 1 standard deviation. Okay, and then you want to look at this area. But then in this question, it's not exactly that, because we have a binomial here, binomial distribution, a discrete sample of 36 Lorentz wing butterflies. And this will be P between 0.0899 and 0.0155. Okay, and for all of these, sample proportion distribution question, and you have an interval like that, you always need to convert it using this formula, L over N. Okay, where L is the discrete random variable of butterflies, or in this case, that have very large wings. And what that means is, next step, you need to convert it to L between this value and this value. That would be 0.0899 times what's N, 36, and this is 3.24, less than greater than. Okay, again, looking at L here, it's binomial, so we can only have a discrete number of it, and therefore we need to change it to integers, 3 and 1. Okay, make sure you don't do stuff like 0 to 4. Okay, that's not what we want here. And that would just be binomial solve will be 0.7380. Okay, double checking with the CAS. 1, 2, 3. Okay, that makes sense, right? Because our probability of getting a very large butterfly is 5.27%, and the expected value of that will be about 1 to 2 butterflies out of the 36. Okay, you have the proportion, you have the size, and you get the value.
So
all right, so yeah.
Yeah, I'm just going to talk about it. We won't answer questions until you're done with this question. But yeah, so with probability, as you can see so far, if you've done a lot of practice exams, you should be able to do all these questions basically, because they're all like pretty repetitive. You just got to know which ones to do. Like they often go from a probability distribution then to like a normal what do you call it? A normal distribution. And yeah, secondly, like Yichen's been sort of using, you can see him sort of use common sense at times in terms of like looking at the graph, will it be bigger than 0.5? And that can sort of help you ballpark your answer. Because usually if you make a mistake, your answer is like a fair bit off what the correct answer is.
Yeah, so use your common sense. It's a very good way of checking, as well whether your answer is correct or not. Okay, if it doesn't make sense, then, for example, you get a probability that's greater than 1 or less than 0, okay, then you know you have made some mistake. Okay, so for the last question, the Lorentz wing butterfly also lives in town B. In a particular sample, an approximation of 95% confidence interval for the proportion that are very large was calculated to be this. Okay, so now for this question, we first calculate the margin of error. Which equals the top, or the maximum minus the minimum, 0, 2, 3, 4, and then dividing that by 2, you'll get did I do something? 0.0316. So basically what that means is you have your average here, which is, well, the middle between that. Just let me check quickly. I think that should be, yeah, 0.055. Okay. And your confidence range for it, so this will have a margin of error of 0.0316. And the lower bound is 0.0234 and 0.0866. Okay, and this is the interpretation for confidence interval. And how do we get this margin of error? There's an equation in the formula sheet that says margin of error, of error equals a coefficient here multiplied by p minus 1p over n. Okay, so the p here might be p hat or p asterisk. And the c here really depends on the level of confidence range you're using. So 95%, we're using 1.96. And I think if you're using for 99%, it's gonna be a greater value. But right now I can't remember on top of my head. So now we solve 0.0316 equals 1.96. Square root 0. Okay. Now the probability p hat would be the middle. Why do I write 556? It's 0. It's not that. 0.055. And that is 0. Yeah. 0.055, 1 minus 0.055. Okay, just plugging it in and you can solve for n. And that's not too hard. N equals 200. The sample size here, it's always an integer. Like, can't be an interval, can't be a decimal place. But the idea here is, first, using this confidence range, we can get the margin of error, which is like the branch of to one side of the expected value. And then using the formula, margin of error equals a constant, which depends on the level of confidence interval you're using, times the square root of p hat times 1 minus p hat over n, which is really your standard deviation. Okay, it's looking at how many standard deviations are you off. And this is kind of saying, okay, if I'm if I'm 1.96 standard deviations away from my expected value, I will include 95% of the data. And what this means, I'll probably better illustrate it here. It's not really symmetrical, but here's the expected value. And here is expected value minus 1.96 standard deviation. And a plus, okay, I'll draw another one. This is kind of tragic.
From what I remember, 95% confidence interval doesn't necessarily mean it's 95% like of the like probability. It means that's like 95% of these intervals. Like if you did 95, or if you did like 100 of them, 95 of them would have the real value in them. From my memory.
I think that's the same thing right here. But what I think is, so you have the expected value, and then you have like the sort of the two arms here, and the probability in the middle should be 95%. I think that should be what it is. Yeah.
All right.
But Darren, do you want to make a bit smaller?
Okay.
Like our faces. Apparently, it's blocking some questions.
Oh, whoops. Cool. All right. Do you want to answer some questions now?
All right.
I'll just answer this early one. Balancing 5 subjects is tough for someone spending a long time traveling to school. I did 2, 3, 4s this year, and I'm in year 11, but I think I messed up once. I'm not sure if I should do 5 next year. So I mean, the year's not over, so I wouldn't say you've like messed up one already. Definitely focus on the exam and try and do the best you can.
Yeah.
But apart from that, I don't think balancing five is tough for someone else to spend a long time traveling to school. I had friends who did it. Also, like on the way to travel, that's also a good time to do some revision as well. I know some people do Quizlet or just go over, do some of their homework that's like really easy to go through just on the way there. But I wouldn't let like a long travel time stop you from doing five subjects.
I think I answered this question. Man. Did I do algorithmics not in BCE?
Did I know anyone from a mainstream public school? Yeah, I know quite a few people who got in from mainstream public school. Like Med isn't like just private school and selective entry. Like there are mainstream public schools who do go there. What subjects? I did methods and Chinese second language in year 11.
Do I need to define the W? So again, like just in terms of understanding, it's good to define. Okay, say what W is. It's the number of no, it's the sorry. Yeah, it's the continuous random variable that follows normal distribution, whereas of a the wingspan of Lorentz bird wing butterfly in Talman. Okay, that would be the definition for it, but it's not really required in exam. And as you can see, I defined probably like 3 or 4 or 5 different variables for it. And if you want to write all of them out, that's probably going to take a lot of time. And VCAL doesn't require it.
And I think we used Cambridge for methods.
Yeah, I think it's a very good textbook.
Yeah.
It's, okay, so I think that's all the questions.
Yeah, cool.
Should we keep going to question 5? This
Yeah.
is the last one. And more, I would say, math oriented rather than application. So we have a function here. Yeah, Darren, do you want to put it on to the cover of question 5?
I'm on question 5, yeah.
Oh, yeah, okay. So we have a function here, all real numbers, 2 all real numbers, and f of x equals to 1 minus x to the power of 3. Okay, so cubic, very, very easy one. The tangent to the graph of f at x equals to a. Note here that a is between 0 to 1. That might be important. Okay, that's a very small range. Intersects the graph of f again at p and intersects the horizontal axis at q. The shaded region shown in the diagram below are bounded by the graph of f, its tangent at x equals a, and the horizontal axis. Find the equation of the tangent to the graph of f at x equals a in terms of a. Now, when we find the tangent, I like to use this one formula. Y minus y1 equals m times x minus x1. M here is the gradient of the tangent, which you can find using derivative. And y1 and x1 is basically one of the points that it passes through. And most likely it will be the point of tangency. So basically this point. And well, let's plug it in. Y minus this. And the gradient, well, I'm not really using CAS here, but negative 3x squared. If you want to put, oh, actually, no, it's better to write this notation. Negative 3x squared. F dash, it's asking for a, right? So negative 3a squared will be this x minus a. And if you rearrange it, which I'm not going to do it here. Actually, yeah, it's just going to take too much space, but I think this rearranging is pretty easy. Plus 1. So find the coordinate of Q in terms of A. That's also pretty easy. We just said, but one thing to watch out for is we don't let x equal to 0. We need to find the x coordinate. So with that, y equal to 0. Negative 3a squared x plus 2a cubed plus 1. So, and you can see I'm not really using calcium, but of course you can. It's just for these questions, I feel more comfortable doing it by hand. But of course, there are questions later on that using CAS would be better. Find the coordinate of P, for example, this one, how we need to use CAS, maybe. So it's the intersection of the tangent and the curve. Y equals 1 minus x to the power of 3, and y equals negative 3 a squared x plus 2a cubed plus 1. And now you'll be using CAS to solve it. 1 minus, you don't have to solve it simultaneously. You can just put in yourself and then replace the 1. And I got two values, x equals negative 2a or a. And we know that at a is basically the point of tangency. So we can, we can exclude that. And notice that it's asking for the x coordinate, not the full coordinate. So we don't need the y value. Cool. All right. So the last question is generally pretty hard, and the first couple of questions, but should be quite elementary.
I'll just answer a question quickly. And not a question, just a comment. I know some schools don't give your SACs back, and also some schools don't give you a mark, and also some schools don't tell you your rank, which I think is really dumb. I think you don't learn anything, and it's also like, what are they trying to do? Like, not make you feel competitive, but like, you're gonna get the end of your exam, and you're just gonna be shocked when you get your study score. So I think schools should, like, you know, if any schools are watching, you should give your SACs back, give them scores, give them feedback so they can improve. That's my thought. Those are my thoughts on that.
Yeah. But like students are competitive students gonna be competitive anyways. They're not gonna not be competitive just because you don't give them a score. So yeah. All right. So the last page of extended response. Let's have a look. Let A be the function that determines the total area of the shaded region. So a very common mistake that one can make here is we do negative 2a to, what's the value of q? To q, which is 2a cubed plus 1. I can't even see that. I'll write it a bit bigger. Negative 2a to and then we do f of x minus, actually no, since f of x is below, then we do negative 3 minus f of x. The problem with this is that we are over counting area. So Darren, can you go back to the previous, the one about the graph?
Yeah, I have both of them on screen at the moment.
Yeah, so if we do it like that, what we're actually counting is we'll also count this area. Okay, so the top minus bottom, we'll count that, and that's not what we want. Okay, so be very careful here. And let's come back. So that's wrong. First of all, we can't do it like that. So I'll rub it out. What you should do is, or what I did, is I found the area of the triangle that has its two vertices at P and Q. And the other vertex is basically the foot of P. So, yeah, and the area.
Try and find regular shapes. They sometimes help, like a square or a rectangle. It's just easier than using
so, and normally I'll just literally draw the shape in like that. This is something I've been doing for a long time. So. That's base times height. And I just want to see the question. So the 2a cubed plus 1, 3a squared minus the value for p plus 2a times the height of p, which is f negative 2a times half. All right? And that's a place where I think you will need to use your CAS. And this is 2 times. Oh, I haven't defined my x equals 1 minus. So yeah, make sure you define that the very first function. This is actually very useful. So that's gonna give you 6a squared, 8a cubed plus 1 squared. All right. So we got the area of the triangle, and now we need to find the area of the curve itself, under the curve. And that will just be, sorry, not 0, but from negative 2a to 1. Now, note that it's not the x coordinate for q, but 1, because we are looking at this area. And then we're using the area for the triangle minus the area that I colored in red. Okay, so be very careful with your terminal what you're setting it to. F of x dx, and that's 4a to the power of 4. What's the value of p again? And plus 2a plus 3 over 4. All right. And then we use the area of the rectangle, the triangle, minus this. And then I think we would get this. 20 over 3a to the power of 4 plus 14a over 3. Making a mistake here. I think I made a mistake here somewhere. Let me just double check.
Is it the terminal? Oh no, you wrote negative 2a. Did you? Oh, you didn't write negative 2, did you? Oh, you did. Okay.
Yeah, I did.
Negative 2a to 1.
The area of the triangle is that's weird. All right, let me do the calculation again. Oops.
Wait, is that the base of the triangle?
Yeah, I think it.
Oh,
it
okay,
is.
right.
So 2 times a to the power of 3 plus 1 over 3 times a to the power of 2. You plus 2a times f of negative 2 times a of times base times height. Yeah, it should give you the correct answer. Otherwise, or not. Oh, never mind. Yeah, now it's all good. I think I made a mistake with in the cast. Plus 2a over 3, oops, my bad. 6a squared minus 3 over 4. Yeah, it's very easy, like, as you can see in these questions, that you made a mistake in like typing in the cast. You probably, so that's why it's important to come back and check it, or just check it right after, see if every number that you typed into the cast is correct. Okay, so now that's the value of a that we have. And note that a is between 0 and 1. And this is very important. Oh yeah, let me just check the domain. Yep, a is between 0 and 1. And the next thing, find the value of a for which capital A, the area, is a minimum. So we need derivative to equal 0, because here, okay, first of all, I think it's better to define it as, I don't know, maybe g of a or whatever on your cast. And then what I'll do is I'll test what happens if I put g of 0 and g of 1 into the equation. And then it says, well, a of 0 is infinity. This is what my cast gives me. And a of 1 equals 27 over 4. So if a 0 doesn't make sense, okay, for the for your area, and for a of 1 that exists. But again, we can't take a of 1 as the value. So we need to diff. So we don't need to care about the endpoints, basically. And here, only we need to consider the turning points. That will be quite enough. And basically, it's a 2-mark question. A gives you this. Okay, if you put it into your cast, solve, and do the derivative at the same time. That should be what it gives you. Oh, actually, no, it gives another answer, which is negative half. Okay, but we don't want that. Outside the domain. So we want a as 10 to the power of negative a third. Now, consider the regions bounded by the graph of f inverse. The tangent to the graph of f inverse at x equals to b, where b is between 0 and 1, of course, and the vertical axis. So now that would be very frightening. If we come back to the previous page,
Yeah.
we can draw the inverse of f, and it'll look something like this. And you can draw it on your cast as well. Okay, so the value of b, and we want to find the value of b for which the total area is the minimum. All right. So let's have a look at where's the tangent of f inverse at x equals to b. So that would be, no. So b is between 0 and 1, right? So not that point, but maybe somewhere here. Yeah, I should use a different column to do it. And what is it asking? What's the area that it describes? The region bounded by the inverse, the tangent, and the vertical axis. Inverse, tangent, and the vertical axis. We can see that it's basically exactly the same as number 1. Okay, so the tangent that we find, or the area that we find above, but in inverse case. Okay, and the x value for is not 10 to the power of negative third. Okay, this is probably has some value of x and y. And this value comparing to the original value will be flipped. So maybe if this is x and y, this value for in the inverse case will be y and x. Okay. So basically I have this point, x equals to 10 to the power of negative a third. I don't know what the y value is. This coordinate, if I construct a tangent, it's going to make the area a minimum. Sorry, okay, not maximum. Now, very similarly, if I also have this coordinate but flipped, and I put it on the inverse function, the area that it describes in question F would also be a minimum, because the relationship between F and F inverse, they are, like it suggests, right, inverses of each other. So the coordinate also inverses. And the value of B would be F of A. Okay, so 10 to the power of third, you put that into your calculator. And that would be 9 over 10. So B equals 9 over 10. Very simple answer, but the reasoning behind is quite complicated. So I maybe go through it again. So if you just look at the original case of f of x, we have this area, the shaded area defined here. And I'm interested in, okay, so what value of A is going to make this area a minimum? And from E, I know that a value of A of 10 to the power of negative a third would make it a minimum. Now, if we jump to the inverse case, the area that it describes here is in fact exactly the same as it describes below, above the original one, that the original graph and the gray shaded area. Except one thing, the point of tangency is now reversed. Okay, originally it's a 1 minus a cubed. Now it will be 1 minus a cubed and a. So to find the x value of that point of tangency, which is going to give the minimum value, I need to find the y value of this. Okay, hopefully that makes sense. It's very, very complicated. All right, find the value of the acute angle between the tangent to the graph of f and the tangent to the graph of f inverse at x equals 1. So this one is actually a bit easier. Now, if you draw the graph of f inverse, it looks something like this. 1, 0. So what that tells you is it has a vertical tangent like this. Okay. So that's very easy. Now we can have a look at the original f of x. So it's going to have a tangent that looking like that. And I can also get rid of that. And what I want to do is I need to find this angle. Okay, note that it's an acute angle, and so I want it to be less than 90 degrees. I don't want, not this one. Okay, so, well, how can we find this? We can find the gradient of the red line first. Well, it's just the tangent of f(x) at x equals 1. So we can find f dash x, which equals negative 3x cubed squared, and f dash 1 will be negative 3. So I'm saying, okay, what this tells us is this line, this red line, will have a gradient of negative 3. And also a reminder that this vertical line is this is a vertical line. Okay, so maybe I'll put this elsewhere. 1, 0. And how can I make sense of this? Well, if I know this angle, let's call it alpha, I can use 90 to minus that angle, and then, well, I get my theta. And the angle for alpha is actually not that hard to find. Remember the formula tan theta. Okay, I'm not going to use theta here. Tan alpha equals m. Okay. This is one way, but probably not the best because it doesn't really help you understand it. What the gradient of -3 means is if I draw a triangle here, and let's say at 2, 0, this point. As I displace the horizontal distance by 1, sorry, the vertical distance would decrease by 3. That's what a gradient of 3 means. So this is going to be 3, and this value is going to be 1. And this angle, let's call it alpha, would obey this 3/1. Tan alpha equals 3. And alpha will be tan inverse 3. Now, be very careful here. Alpha is an angle between 0 to 90 degrees. Okay, it's a positive value. And to find theta, we just need to use pi/2 minus tan inverse 3. So this is our acute angle.
Yeah.
All right. So the last core question, quite a bit. So maybe just to summarize some of the hard questions, F and G in the last question, and the probability is quite straightforward. And there's a couple back.
You're going too fast. Just let me know what page you're on. I found you.
Oh yeah.
Oh, good.
No, it's fine. I can tell you like where it is. Yeah, 3E. 3E is definitely hard. And this one I circled. So this is 2E double I, 2EII. Not easy.
Yeah, thank you very much, Yichen.
Okay.
Just a couple of things.
So good.
Yeah, thank you. With the last question, two things I would say about this. One is yeah, so you see like there's a lot of thinking involved with these questions.
Yeah.
And one's worth 2 marks, one's worth 1 mark. So like yeah. Secondly, with G in particular, there is a formula for finding like tangent between two lines, but I would much recommend you guys to sort of do what Yichen's done and what I did, which is to draw the tangents out, because you can actually see the angles. And also it's better to work with angles we sort of understand. So treat alpha as
Yeah.
like an angle between 0 and 90 rather than sort of like negative like 45 degrees or something like that. And that way you can like actually understand that theta would be 90 degrees or pi/2 minus that positive angle there.
So another way is tangent theta equals m. This is one we know, right? But it's kind of dangerous to work with this here, because if you don't fully understand what it's doing, it's very likely that you're gonna get some wrong answer, right? Because this theta can really take on infinitely many values. If you're not careful, if you don't know like the domain and range for arctan or tan inverse, really easy to make mistakes.
So I remember sitting this exam, my answer was right in the end, but like I wasn't really sure what I was doing. Like I got tan inverse and I was in year 11, and so I had no clue what like tan inverse really was. And so I sort of just put it down and it was right, but it's like confusing.
Yeah, Darren, I'll be back in real quick. I've got to leave for a bit.
Yeah, no worries.
Yeah.
I'll answer some questions in that meantime. It's fine. Yeah. When you guys come back, just thank Yichen. It's a lot of effort doing an exam too, and he's graduated as well. So yeah, I really appreciate him spending this effort. Alright, so Ace asked, how would you recommend studying from today to the exam? So definitely, I always recommend you guys do this, which is to figure out what you want to get done before the exam. Right? Otherwise, you're sort of just like waiting around, doing a couple practice exams here, not really sure what the final destination is. So figure out, hey, okay, I want to do all the VCAR exams from 2010 to 2020, and then like plan it out and do that. What I'd recommend you do, definitely do say like 1 to 2 full methods practice exams every week. I think there's only like 4 weeks, so probably opt for the side of having 2 full VCAR exams per week, and company ones if you feel like it. But VCAR is definitely like king. A lot of Melbourne High School and McRob chat here, but yeah, I don't think it's good that people don't get their sacks back. But I also have heard that a lot of schools have random sacks in terms of that their sacks are a lot harder than the exam and are very abstract, which I also don't think is a good idea. Like it doesn't help you at all. All right. Also, if you guys have any questions, drop them below. We're like happy to answer all the questions now. I'm not sure whether we'll do multiple choice, so do let us know if you'd like to. But yeah, yeah.
Yo,
Can
I'm
you hear?
back.
Cool. So there's a question sort of for the both of us. How did you structure your final weeks to cater towards exam prep and balancing subjects?
Uh, exam prep. So my last couple of weeks, not just last week, but I basically, so I told you I planned this with Jim, right? So we go to school like, basically every day, a work day, and then we will plan like, okay, what exam paper we'll be doing over the next 2 weeks. So maybe Monday we'll do English, and Tuesday we'll do maybe do a method exam one and a special exam one. Okay, so on and so forth. And I think that was pretty chill for me because we kind of had to have a plan of what we will be doing, and yeah, that's sort of what I did. Okay, so I planned my what I'll be doing every day.
Low key, like doing exams with your friends is pretty fun. I did it online mostly with my friends, like I'd video chat them. And it's sort of like I'm on the way home. I'm like, I want to do a practice exam, but I don't feel that motivated. I just tell them, okay, let's do one when I get home. And then you sort of have to do it because you can't really disappoint them. But balancing subjects, I think naturally, you have certain subjects you need to spend more time on because you're not happy with where you are, or because they just need more effort, like memorization or orals or something. And I think allocate that accordingly. And unless you have a extremely obvious bottom two, then there's no need to like really cut down on a certain subject.
So I did. I'm doing. I want to do data science in Melbourne Uni, so it's like computer science related, and probably become I don't know data engineer, data analyst,
Illicit.
analyst, analyst, yeah, data analyst in the future. Yeah, that's something I'm planning to do.
Yeah. Um, I did do VCAR exams. I made sure to do all the VCAR ones, because I thought that'd be helpful. How about you, Yichen?
Oh, sorry, the VCAL ones.
Yeah.
The VCAL, yeah, I think the VCAL exams, yeah, I think more helpful than the company ones, because they really they stick to the study plan, the study design, and they're not gonna have extra stuff, right? That's not tested. So Darren, do you want to do a couple of multiple choice?
Yeah, sure. Let's just finish answering these questions and then we'll
Yeah,
jump into
yeah,
multiple choice.
yeah.
Cool. Who's the character in my Instagram profile picture page? I don't know if you guys like watch anime. There's this or read manga. There's one called Tokyo Revengers, and he's sort of like he's not the main character, but he's like the guy who the main character is trying to sort of solve or sort of resolve the problem. And yeah, his name's Mikey. It's a pretty popular one, so yeah. Thank you very no worries. Big Nono. Yeah, yeah, I thank you as well, Yichen. There's a lot of effort for him, so thank you.
It's sharing the knowledge, right? Helping everyone.
Andres, I'm not sure how to pronounce your name. Dokar next year. Okay, this is not sponsored by him in any way, but he's legitimately like a goat. He's an excellent um tutor. He's amazing. He got 650s. He explains things so clearly, so well, goes through all the key questions, and he has a very strict and clear plan for you guys in terms of exam revision. So I think it's excellent that you've gotten in. Definitely, like if you see him, just let me know. Like tell him that you sort of know me. I think it'll be pretty cool. I sort of regret not doing that well in chem and spec because I had excellent tutors and teachers for those. Um, but yeah, he's excellent. And Victoria has a question, which is has been said numerous times. But you want to go first, Yichen?
For specializing method, I kind of do the same. About 20 each, so not too much, I would say. I feel like I don't think it's amount that sort of is the key thing. It's about how you learn from doing these exams, right? And what I'll do is, and I've said it. So for every exam that you do, look at the mistakes that you made. And what I did is I put it on the front cover of like every exam. Okay, so where I lost a mark and that, and like this, you can learn a lot from it, and you won't repeat your mistakes really.
I'd say because you don't have that much time, don't feel like doing a ton of exams will sort of make up for it and you'll do well. The best way to do it is sort of cut your losses in a way. Not really like losses, but like don't feel like you have to do everything. Pick the most recent ones, plan out when to do them, and then do them. In general maths, it's better to do sort of more-ish compared to other subjects. Whereas I don't remember your other subject. I think Chinese practice exams are pretty good. I think you do lit. Lit's like
I don't want
lit
to talk about Chinese. Like, such
lit practice exams are, I mean, it's kind of like English. You can do separate sections, I feel like. You don't have to do it all together. And spec and methods, just, it's maths.
and Victoria missed a bit where I talked about how I study with Jim. Yeah.
Yeah, okay. Yeah. What's the most important thing to include? We'll answer this question, I think, and then we'll do some multiple choice because Yichen's keen and I appreciate it. What's the most important thing to include? For me, and this is from Derek as well, is to have on the front page your silly mistakes. So, okay, I don't have mine with me, but on the front page I had silly mistakes. So I had like decimal points. I had what else? What other silly mistakes? Like read whether it's tangent or whether it's coordinates. A lot of common ones I made. I also had some CAS annotations. Like for spec, they don't have Euler's CAS right on your formula sheet, but the Euler's CAS is kind of complex, and so is I think differential equations. So I sort of had that in my bound reference as well.
Hey, Darren, do you know how many marks do you need? Like, can you drop in spec to get a 40?
40. Oh,
Not sure, but
if you want to know how many marks you can draw to get 40, go to VCAR statistics, exam statistics, and they have A plus. They have a plus range for exams, and that's the range for 40 because 40 is A plus. So you can check how far into A plus, how far off A plus you are if you go to VCAR statistics.
yeah, I'm not sure about that range. But I know for method it's like 15, is it 15 to 20? I don't know. Like for method,
I dropped 9, so I'm pretty sure it would be a bit more, probably more to the 20 side overall.
yeah, I think.
Yeah.
What's EL exam?
English language.
Oh, okay, that's not.
I did probably 3, I think. One for school, like they're all for school, but one was like one that was mandatory. We all had to sit it. Feel confident with timing. Timing, it's not really how many you do. I was pretty good with timing because I was pretty good at the subject. But in terms of like, you should just do as many as it takes for you to be accustomed to timing. And any like, you can practice the individual sections as well. And you sort of get used to seeing what it's like to be behind, what it's like to be ahead. And when you get in the actual exam, timing's like second nature.
I think it's a really good question. Like, when you can't really improve by doing more questions. Once you reach that level, like the most important thing would just to get your mindset right. Not to be overly nervous or stressed out for exam, because doing more questions, I think when you're at that level, it's not going to make you improve a lot. Oh, like really. So yeah, make sure your exam mentality and all the stuff like that is all right before the exam.
Yeah. And yeah, like learning from mistakes is a big one. Like I sort of from my speech tutor as well, but if you imagine that you learn from every single mistake you made in every practice exam, right, which is possible, um, and like what's the chance that you'll make that same mistake in the actual exam? Like it's very low that you'll make like you drop 10 marks because probably 8 of those marks were mistakes you've made before. So that's pretty important.
Like from my experience, even like what I do, right? I write my mistakes on the front cover of every exam. Like I still make mistakes. I still make the same mistake sometimes, but not too frequently. And that sort of shows if you actually can reduce these mistakes down, then your marks will really be improved a lot.
Yeah. Do you know Chia?
Cheer.
Oh, like the person who commented amazing Yichen with like 200 emojis.
Oh, QR. No, I don't. Maybe I do, but
Big fan, big fan.
I know who's QR.
Did I handwrite? I handwrote parts of it, like some of the like Euler's annotation for Kaz or like my silly mistakes. I handwrote it, but the other questions like it was like I printed out like the questions I got wrong.
All right, Darren. So come back to some MCQs.
Sure.
I'm not probably planning to do all of it. Just some I think is probably important.
Do you have any like? Do you want to do the ones you
Yeah,
think are
19.
important? Okay.
Do you want to start with 19? So this
Starting
one
with
I think
19.
is not
Right, let's go.
pretty hard. So given that 10 alpha equals d, where d is greater than 0 and alpha is between 0 to pound 2, so it's a lot of restrictions on it. The sum of the solutions to 10 2x equals d, where x is between this range, in terms of alpha. So we want to find the sum to all of its solutions. So you might be thinking, okay, how do I do that? Right? My approach to this was I first understand what 10 alpha equals d actually mean. I drew a graph for it, and since it's really between pi on 2 and x equals pi negative pi on 2. So I have this alpha somewhere here, and I have this solution d. Okay, and now I have a new graph, 10 2x equals d. Now you notice a difference in domain. This one is now pi over 2. So the new one I'll probably draw in red. It'll look something like this. So x equals negative pi over 4. X equals pi over 4. And x equals, you plus another pi on 2, 3 pi over 4. And you plus another x equals 3 pi over 4. Okay. So you draw the graph for it, and it's not a very good graph. Well, and the value of d will be somewhere here. Like it will be the same value, right? But what's happening to alpha? Alpha is getting pushed backwards by half. So originally, well, you can think of this 2x as dilation of factor half from the y-axis. So like all the whole graph is squeezed inside. The period gets halved. And so originally, it has a value of alpha. Now it would have a value of alpha over 2. And if you draw a line across it, each of the value will be incremented by pi over 2, which is its period, plus pi over 2. Well, I feel like it's getting a bit messy. Pi over 2 plus pi. And if you want to sum it, it would be 3 alpha over 2 plus 3 pi over 2. equals 3. What is it? Pi plus alpha divided by 2. Okay. Yeah, so that will give us option E. And yeah, this is dilation. Like if you squeeze it inside, it's dilation by a factor of half from the y-axis, right? Yeah, I think it is right. Then just to check.
Dilation.
Yeah. So this one, it will be like if you squeeze the curve towards the y-axis, it will be dilation by a factor of half from the y-axis. Like is it from y-axis or x-axis? But this one should be. Yeah, this one should be correct.
From y-axis.
Yeah, it should be from the y-axis.
Okay.
So some other question. Okay, 18 I think is worth going through.
Cool.
I'm not sure because you said this exam, right? So what do you think it's kind of you're not very confident with? I'm sure if you can remember.
I think I dropped 1 mark in multiple choice. I don't remember exactly which one I dropped a mark in though. But I remember this one was like relatively difficult. Like there was a bit of thinking involved.
Okay, so we have this very weird looking graph here, and it's the distribution of a continuous random variable. Okay, so continuous, we're thinking about intervals here. We're not thinking discretely. It's defined by the probability density function f. So basically, it's probably not the best representation, but it should be 0 everywhere else. Okay, so where f of x equals this p of x, and p of x is shown here, and 0 otherwise. It is known that the average value of p over this interval is 3/4. And just to sort of remind, so the way you calculate average value would be, so average value would be 1 over, okay, b plus a. This is negative a, but normally it would be from a to b, right? F of x dx, where this, okay, represents the net side area. Okay, net side or area over its width. So you might think of something maybe here, okay, where the area of the rectangle equals the area under the curve in this interval. Maybe it's a bit, a bit higher than that, I would say. Something like this might be better. So the area and in green can really be filled into the area in red. All right. So we start this question by thinking of, okay, what do we know about PDFs, continuous random variable, probability density function? First of all, area represents probability, and it should equal 1. Let's find the area. It will be the triangle plus this shape to the right. Yep. Now for the area of the triangle will be a times, is it 2a? Yeah, 2a. I don't know why my iPad is like this. Times half plus the other one will be 2a plus b times b divided by 2. Okay, this would equal 1. Let me just check I got the area calculation correct. All right. Okay, now the other thing we know, well, this is from the feature of a probability density function, right? We also need to think about, okay, how can we do anything with this average value? Because right now we have a and b, the two variables. We cannot solve two variables with only one equation. We need at least two equations. Well, the average value as we are given is 3/4, right? And the net signed area between negative A to B would be 1, right? And from negative A to B, and then we need to divide it by B plus A, which is this length. Okay, divided by the width, or if you want, or the length. You put that into a simultaneous equation. AB times A plus so it should be some pretty weird answer. A equals negative √2/3 and B equals √2/4 plus 3, or A equals √2/3, B equals, what's the last one? 4 minus √2/3. Okay, now we need to choose. We know that in this case, A and B are both positive real numbers. So we would need to discard this one and go with this. If you have this, then the probability of x greater than or greater than 0 would just be, well, this area. Okay, and that's 2A plus B, B/2. Sub this in. 2 times, plus 2. So that's gonna give you 7/9. All right.
There's
so
one
that's
thing. Oh, you go.
Yeah. Oh no, like what were you trying to say?
I was just saying one thing that's annoying about this question is that the way I remembered the area of a trapezium was a half A plus B, times like height. Whereas for this they use A and B, so it's like kind of annoying.
Yeah, exactly. I guess, yeah, when I did it, my point of confusion is the integral just simply the area? Because we used to see functions that are defined kind of continuously and smooth. And here there's like an intersection in the middle. So is it really just the area? And that sort of confuses me when I did this as a practice exam.
So that's where sort of understanding. People always ask like, what does understanding mean? Sort of knowing whether like what the formula means. What are you actually finding?
Exactly. So, for example, like this integral, right? Some people might just see it as a sort of a symbol with like dx over it, and you have some. You must have some number at the terminal. You have some integrand, but I sort of see integral in a different way. So, if you have, let's say, f of x dx a to b, I feel like giving a like lecture about integration. Yeah, so if you have a curve like this, so this is like how you can think about integration. A and B. I kind of think of it as sort of separately. F of x, dx, and this symbol to the left. For every point, f of x will be its height, right? And I think we've all, I think we know like how we derive the integral. It's kind of like area, right? We divide it into a lot of rectangles. Yeah, like this. Okay, I'll just draw it in. And you can really treat f of x as the height of each rectangle. This is f of x. It's getting quite thick. And the increment or the width of every rectangle is dx. Okay, and the terminal is basically a sum. So this is, as I remember it, a sum. You can see it as a sum from A to B. So basically, okay, A to B, you cut all the rectangles and then you sum all the area. And that's easy or easier for me when I understand, to understand things like this. So for example, I have another curve like this, okay? And I want to find the area A and B, for example, here. Okay, and what that means is, well, all the, so any way of going back. Yeah, so for all the things that will be changed would be this middle value. So the integrand, it will be A to B. Let's say this is F and this is G. F of X minus G of X dx. Okay, so dx is still the width of every rectangle, but then now f of x of minus g of x will be the height. Okay, it will still be the height. Like this. Okay, as you can see, the height will be just the height of the height of f minus the height of g. Okay, and yeah, that helps me to understand integrals a bit better, like that. So the symbol as a sum, the integrand f of x as height, and dx as the width. All right. Is there any other? Let's see if there's any other questions that I think it's worth it.
Yeah.
Worth going through.
Tips for learning proofs is a question.
Learning proofs. I think proofs is really the fundamental of mathematics. And that's where like sort of I would say rigorous math comes in, right? You want to be you want to know, okay, where does this integral, where does this sum come from? Okay, where a lot of the symbols or the definitions that we use come from, and they're from proofs. Tips for it, I guess really to think through what the proof is actually doing, and I don't know. It's hard for me to say like any tips for it. And think about, okay, first of all, you need to make yourself believe the statement that you're trying to prove. And then, okay, if it makes sense, if it doesn't make sense for you, then it's really hard to prove it later on. But okay, so think about it first. If it makes sense to then try out a lot of different things. Okay, is what I would say my work improves. And I guess the thing to watch out for proofs is that you need to make sure every step that you do is valid and correct. You can't assume things that, for example, cannot be assumed, I'd say.
Yeah. So with proofs, I wasn't that good at them, but what I would say is you don't have to know where you're going necessarily. Like you sort of work with what you have. You look at the numbers you have and you see, okay, what can I do? Oh, I can find the integral, or I can find the area of this. And then you sort of just do that and then see where that takes you and see where that takes you. It's usually quite rare where you know like this will lead to this, will lead to this, will lead to my answer from the start. So I'd say sort of go with what you know and just find random stuff and think about whether it might prove what you're trying to find.
And I think it's quite largely related to like mathematical intuition. How you think about how you like react with numbers and all that.
I answer Elvin's question. Do I think Derek Haas better than Breakthrough? From what I heard, I never went to Breakthrough. From what I heard, Breakthrough is like pretty good. But I really can't imagine like a better maths tutor than Derek for me. Like, yeah, he's really good. I would probably recommend him. I don't know. Did you go to tuition? You did, right, for maths?
Oh, me? Yeah, I did. I went to first ed in Boxhill, and yeah, they're pretty good as well. I think all the other questions are pretty basic. It's not much.
All right.
What do you think?
Well, I'll just have a quick flick through them. I think there are a couple MCQ questions like in the chat if you wanted to answer them. I'll have a look through if there are any hard questions.
Yeah, if you have any questions that you want me to go through them, yeah, that's fine as well.
As in, there are a couple questions in the chat about
About the one we just did.
no, about So one was how quickly did you do MCQ, and secondly was did you start with MCQ first?
Okay, so yeah, I did start with MCQ, and this is what my tutor told me. So during reading time, look at the question. Just look at the multiple choice question. I know this is a different approach to yours, but look at the multiple choice and then see how many can you do already. For example, if you can do like question 1, 2, 3, 4, 5, I don't know, 7, 9, then like remember the answer, and when the reading time is over, you can like circle it straight away or put it into your like write down your answer straight away, and then there will be like about 12 multiple choice questions left for you to do, and that'll be a very good head start, I would say. And he didn't think like looking at the extended response is a good thing because you can't really see anything from it. Like, you can't really see an answer, or you can't really see it. Yeah, there's no point looking at the extended response straight away. But I know that's a different approach to how you did exam 2. So
Oh yeah. I was just looking at the multiple choice. I don't think there's any other hard ones. If you guys have any particular requests, then go for it. But yeah, so I went through extended response first. My tutor sort of recommended that I get my head around what's happening in the stories and just do extended response first, and then spam or like speed run the MCQ towards the end, because kind of you can guess. I guess that was, I don't remember the exact reasoning for it, but it sort of worked out well for me because it took me a little bit of time, especially for methods, to understand what's going on, and I quite liked being able to sort of figure out how A led to B led to C in extended response.
the question about 2013 exam 2, in where you need to find the gradient of the tangent in terms of k, and most of us they couldn't find it. In those cases, can you make a reasonable value for the gradient of the tangent and get consequential marks? Look, I think for these type of questions, right? Like it's more like 5% or even less of the state that gets it, and it will normally be, as we have seen in this paper, 1 or 2 mark really. And so it's really unlikely that you will make a reasonable guess unless it's correct, of course. Make a reasonable guess and then give and get any consequential mark. But if it's more than 2, then well, it's having an answer is definitely better than not having anything on your exam paper.
I think usually they don't, like if it's a really hard question, they usually don't force you to use it later on, or they sort of tell you the value. They say like,
Yeah.
let this be this, because otherwise, like if you can't do one question, you're messed up for the rest of it, and then try and avoid those situations. So that's probably why 2013 was a while ago. Probably why they had something like that. And in that case, I mean, the best you can hope for is write in a random value and then use it later on, if you have to, because it's better than leaving it blank, I guess. But yeah.
And I think this is for physics and chem, right? So if you, for a previous question, you write like whatever value, and then you use that value to keep calculating, I think they'll only count that question wrong, and the later questions you'll get it correct.
Yeah, I'm just having a look at that question now. But hello, Kianan. Kianan's been to quite a few of my streams. He goes to Scotch as well, if you know.
I finished MCQ in about like 20 minutes. No, actually a bit more than that. Probably 25. Yeah.
Yeah. AJ, could you tell me which question it is? I'm not too sure which one. I'm just curious to have a look. And I aim to finish MCQ in 20 minutes. I think methods was okay. I think 2020 I didn't do it because I thought the questions were quite hard. But usually I'd aim for like a minute per question.
So I assume it's one of the extenders. Value of k. Oh, is it? No, 8 marks. Is it question 1?
4C.
Oh, 4C.
Yeah. part of the graph of a function is shown.
For C. Part of the graph of this.
From what it looks like, the gradient doesn't seem. So, okay.
Wait, Darren, do you want to have a look at this question?
Okay. Let me try and do this.
See if you can. But just I haven't looked at it for quite a bit, so.
Oh, you guys can see my screen. All right, cool. That's interesting. I'll paste this into the board. We can have a look at it. Yeah. This is very technologically challenging, honestly. Like the first time I tried streaming, it was actually so hard. Like, right, is it pasting? Is it pasting? All right. I pasted it below the exam.
Yeah.
I will expand it. All extra. 3, 2, 1. Okay. There it is. Did it just delete itself? No, there it is.
Oh shit. Okay, so we can have a look at question 4.
I'll make it a bit bigger.
So this is alright. Hopefully I can do it. If I yeah. So part of the graph of a function. Again, I'll define it. Right, define it in my case. Define everything. Define g of x here equals 16 minus x squared over 4. This is more. I'm feeling more nervous than the actual exam. Yeah. So point B and C are positive x-intercept and y-intercept of the graph of G. Oh, okay, he just left. So what I'll do is I'll probably find the values straight away. It might be useful, might not be, but it's just like a habit. C is zero form. You put x as 0 into it, and B will be, if you solve it, it's 4, 0. I'm not sure if you guys can see this. Yeah, correct. Points B and C are the positive x. Okay, and as shown in the diagram above, the tangent to the graph of G. The graph of the tangent to the graph of G at the point A is parallel to the line segment BC. All right, so let's have a look at the gradient. Gradient will be 0 minus 4, 4 minus 0, so that's -1, right? And we note that the x value of A, maybe I should say, has a domain. Domain is really important between 0 and 4. Okay, so somewhere between 0 and 4, I'm gonna see a point on the curve of G such that the gradient is -1. So I'll need the derivative of G. And that's -x/2. And I want to make that equal -1. Okay, and x would equal 2. But that's not the entire question. It asks for the equation of the tangent. So when x equals 2, g of 2 would be 3. Okay, and then you use the equation, the formula. Oh, this is one that I like to use a lot. Y minus 3 equals -x minus 2. Plus 2 plus 3.
And really easy to check, right? You can just draw both graphs.
Yeah.
along a similar line of thought, you just sort of like look at it, right? -1, the gradient's negative, makes sense. Y-intercept 5 makes sense. Yeah.
The shaded region shown in the diagram above is bounded by the graph of G, the tangent, and the axis and the y-axis. Again, if you do purely integral 0 to 5, the tangent minus G, that will be a mistake because you will be evaluating this part of the this area. So the approach will be pretty similar to 2019, and find the area of the triangle.
See how problems repeat themselves 6 years apart.
Like 5 times 5 times half, so 25 over 2, and then you find the area that I color in red. So A red will be 0 to 4. But I aim to get through this pretty quickly because the hard part's later. And that will be 32 over 3. Okay, and the final answer would just be a shaded 25 over 2 minus 32 over 3. 11 over 6 units squared. That cubic point on the graph of y equals g of x. So this is the next question. Find the positive value of x coordinate of g for which the distance OQ is minimum, and find the minimum distance. Positive value of the x coordinate of q. So for which so we need two things: the value of x and its distance. And note that the domain for q here is strictly greater than 0. So that's that. Let q be, I don't know. Let's give it a value. A.
A, B, or A.
Like A
16,
and
yeah.
16. We don't want to over introduce variables here. A 16 minus a squared over 4. And it's the distance OQ will be a minus 0 squared. So that's the distance formula, plus 16 minus a squared over 4. It should be a minus 0 cubed, squared. Just write that in. And maybe I'll set that as length. Okay, so length OQ equals length of A. And I want to find the derivative of length in terms of this arbitrary A that I created. So I'll probably write length a bit better. A squared plus 16 minus a squared over 4 squared. Squared. Yeah, so this is and the good thing about having it as a fraction is that when we evaluate it to equal to 0, the only thing we need really equal to 0 is the numerator. As long as we make the denominator, as long as the denominator is not 0 for any of the values of A, and maybe we can check that. Okay, and for the positive values of, okay, so here we will have 3 values of A equals to 0, A equals to negative 2 root 2, 1, 2, and A3, 2 root 2. Okay, basically we can reject this, and well, the value of A would now be 2 root 2, and L minimum will be, okay, technically, right, this we only found the stationary points. We haven't discovered if this is a maximum or the minimum or a stationary point of inflection. But in this kind of application question, I think you can really just assume that.
Yeah, there's no real other place it could be because there's like no
Yeah.
endpoints. So where else is the minimum going to be?
So I'll just sub that in 2 times root 2 plus 16. So our minimum is 2 root 3. Okay, so make sure you answer the minimum distance and the positive value of the x coordinate. So that's why setting up this domain of q greater than 0 is really important in basically all the questions. All right, now here's the hard part. The tangent to the graph of G at a point P has a negative gradient and intersects the y-axis at the point 0k, where so k is between 5 and 8. Find the gradient of the tangent in terms of k. Okay, so this is 2 mark. All right, let me have a look. Tangent to the graph.
I think one thing you guys can sort of realize is that the gradient has to be more negative than -1 because k is bigger than 5, right? Whereas k was sort of 5 for the one where gradient was -1. Just something to keep in mind.
Yeah, all right. So what we can do is a very famous way is we set this point to be at P be, I don't know, I think I used A above, right? Let's use B. B 16 minus B squared over 4. Okay, so the gradient G dash X is negative X over 2, right? So if I put B in, it will be negative B over 2. So now I can have an equation y minus 16 minus b squared over 4 equals negative b over 2 x minus b. And this is just the equation of the tangent for the line. I haven't used this information yet. And now we can have a look. When x equals to 0, y equals to k. Minus 16 minus b squared over 4.
Wait, Yichen, I'd have thought, I'm wondering what you think. So you know how you use your formula where y minus k equals m brackets x or mx?
Are you thinking if I can use that, right?
Yeah, because then you can just solve that equals the parabola, and there should be one solution.
Then for b, you wouldn't know what it is.
Pardon?
Like for this gradient of negative b over 2. Like, do you mean y minus k equals negative b over 2x?
Don't you use mx? Isn't that like your tangent formula thing where you have a point and you don't know the gradient, and you know the gradient?
Yeah, that's so y minus y1 equals mx minus x1. Do you mean that?
Yeah, so you can sub in 0k, right, for that?
But yeah, you don't know m though.
Yeah, it's fine though. And then you because and then you solve because you know the equation of the parabola, I think. You know the equation of the parabola.
Yeah.
Right? And you know if the intersection with the parabola is you only have one intersection. Right? So with this you have an equation in terms of like m and k. With the parabola you don't have any m and k. So you can just solve that. Like I feel like there's something to do there with maybe discriminant or something.
Yeah, maybe. How about I'll try the method afterwards,
Yeah.
and I'll see how well I go with this one. So k minus 4 plus b squared over 4 equals b squared over 2. Yeah, and k minus 4 will be b squared over 4. And I can, it's taking really quite a lot of space. 4k minus 16 equals b squared. And here, b is positive. So I can take b as 2k minus 4. All right, and I can sub that into the original equation. Y minus 16 minus 4k minus 16 over 4 equals negative 2 root k minus 4 over 2 x minus 2 root k minus 4. What is it asking? Find the gradient of the tangent in terms of k. Oh, you don't even need that much, right?
Oh yeah, you can just rearrange this and do
Yeah,
it.
you don't even need a equation. It's just the gradient. So you just need this one. So the gradient equals negative b over 2. And we have found b in terms of k. Negative 2k minus 4 over 2. And this is negative k minus 4. This makes sense, right? Because gradient should be, as Darren said, a negative value. And well, here we got a negative value here. So coming back to the point that you mentioned, so you said y minus k equals.
One more thing. Can I say one more thing? Yeah. Also, apart from being negative, right? I said it has to be sort of less than -1. So if you think about the bounds of k, it's between 5 to 8, right? So if k is 5, which is the minimum value, you get -1. So it has to be like yeah. So if it was equal to 5, it would be -1, which kind of makes sense. Because
Yeah.
the previous question was that. Yeah. So Yichen's one is that's sort of a way to check it, I guess.
So y equals mx plus k, and then you said this, if you intersected with y equals, what is it, 16 minus x squared over 4, right? You should only get one equation.
So discriminant equals
Yeah, I
0.
think that looking like it's gonna work. 16 minus x squared over 4, if you want to solve it, mx plus k. 4mx plus 4k, okay, it's just some algebra. 0 equals x squared plus 4mx plus 4k minus 16. So the discriminant would equal 0. 16m squared minus 4ac, so 16 would equal to 0. And the gradient, you can divide it by 4 on both. Minus 16k plus 64 equals to 0. I'm running out of space. Yeah. Well, yeah, I can
Yeah, you
divide
could
by-
divide it by 16. But
Yeah, 4. Oh shit, why am I still running? So m squared minus k plus 4 equals 0. And m squared equals k minus 4. Okay. And ultimately, we have the negative square root. So yeah, I guess this is a very good way of doing it as well. So here's the two ways you can have a look. So gradient is negative, so we take the negative square root.
I think my way might be a little bit more like, I feel like Yichen's way is more solid in terms of that, like with any general tangent one, you can sort of assign values to P and then sort of get started straight into it and get your answer. Whereas with my one, you sort of got to like realize there's like one intersection point, which usually isn't the focus of a tangent question.
But nevertheless, I think if you know more methods, right, it's probably a question that worth circling. Like circle it and then come back. I'll use another way of doing it. Maybe using this.
And Kianan, I think so. Like I don't remember. I remember Woolacott gave us a lot of like good questions. This may have been one that he did. Yeah, but hopefully that helps AJ.
So do you want to keep going? Yeah, let's finish this question.
All right, let's finish this question.
4C. Oh wait, did he just ask 4C?
Yeah.
Do you want us to finish it, or maybe we can?
Are you asking me or him?
Or him.
Okay, cool. We'll see if he replies.
Replies. Yeah, I can have a look at this question as well. Yeah, generally the last question is, as you can see in this case and the 2019 one, they are all very, how do I say it? Like math, not much application going on here. It's just like math formulas and functions stuff.
He said, if you want.
Okay. Yeah, I can keep going.
Thank you.
So find the rule AK for the function of K that gives the area of a shaded region. Well, so now we have the gradient, and then we have one value of the we have one point on the line, so we can make a gradient. I mean, we can find the equation of the tangent. Okay, so y minus k equals negative. I have to x y equals negative k minus 4x plus k. Okay, so we have the y-axis intercept. We want to find the x-axis intercept. So we make y go to 0, and we try to solve this. K minus 4x minus k equals k, and x will be k over square root k minus 4. Okay, note again, this is the x-intercept for the tangent. All right, and this is only valid because square root of k minus 4 cannot be 0. If it's ever 0, then we cannot do the division. So that's why check the domain since k is greater than 4, so we can do it. Right, between 5 and 8, in fact. So like in the previous section, we will start by finding the area of the triangle. And that is slightly harder here. K base, this is the base, times the height times 2, times half, I mean. And that's k squared over 2 square root k minus 4. And I think area under the parabola is the same, right? Area under parabola is still 32 over 3. Let me just check again. Yeah, 32 over 3. And hence, AK would be k squared 2k minus 4 minus 32 over 3. This is the 2013 exam. So we finished the 2019, and this is a very good exam question. So have a look at this. Yeah, so k squared. All right. Find the maximum area of the shaded region and the value of k for which this occurs. All right. So make it a bit general here. So in general, how do you find the absolute maximum and absolute minimum of just a function? All right, Darren, do not scroll down to the empty section in the end. It's just above,
Sure.
yeah, questions and answers. So think about if you have a function that maybe looks like this. Yeah. I'm just drawing a little section. So maybe the domain is bounded to here. Let's say this is A, FA, B, FB. Okay. Now, as I said before, if you have listened, then the absolute max and min, okay, they will exist in this couple of points. D, FD. So they'll exist in X equals A, B, C, D. And for A and B, they are the endpoints. And for C and D, they are the turning points. If you look at this one, the absolute maximum is FA, right? And it exists at X equals 2A, which is an endpoint. And the absolute minimum is CFC. I think I'm missing a bracket here, which is a section point. So it makes sense that all we need to check is the endpoints and the turning points. So the first thing I'll do is I'll test what A5, the boundary for K is 5 and 8, right? If I remember correctly, 5 and 8, yeah. A5 is, okay, you can define it. F of, in this case. So A5 is 11 over 6, A8 is, because they're really easy, right? You just plug it into your cast and then you see what are the values. Okay, there's not much thinking here. And it can avoid a lot of neglected answers. Okay, and now let's have a look at the derivative and the turning points. A dash K equals 0. Again, we don't need to write down what that is. We just need to give the examiner, okay, this is the value, and we are solving it. And we get K equals 0 or K equals 16 over 3. Again, we know that that's outside the domain, but 16 over 3 is, so the last value that we need to check is 16 over 3. It's actually this value, but yeah, 16 over 3. All right, this is the 2 mark question, and this is very strange value. Okay, and that's okay, approximately 1.65. And now you know that if you just compare these 3 values, because these 3 values are all that's possible, all the possible values of absolute maximum and absolute minimum, and we can just say A max equals 16 over 3, and don't forget the value of K equals, what is it, 8. And lastly, this minimum area, which we have calculated before, a minimum. Again, you compare the 3 values, right? 1.65 is definitely less than 11 over 6, which is 1.83. So maybe I'll write that in. So equals, and you want the exact value, 32 minus 3, and the value of K for it is 16 over 3. So 2 mark question, really, this is all you need to write. 1 mark for the minimum value of A and 1 mark for the value of K. Okay, so in the end, I think this one is actually not as hard as C. So always look to the end. So maybe the last question you can do, but the question before that is harder than that. And yeah, always attempt every question would be the answer.
Yeah, because you don't really, do you need the tangent or not for, for D1?
D1.
Yeah. Did you need to use the gradient of the tangent? Oh, you did.
Yeah.
Yeah, you would have had to. Yeah.
What I did, yeah, I found the equation of the tangent. Okay, then I can find the area of the triangle.
Coolio.
Okay. 2020 exam 1 sometime. How about let's just do that now? But is it random? So if you have any specific questions in mind, because I said that exam, I think Darren said that as well. Maybe we can answer it for you.
Yeah.
But we don't want to spoil it for other people.
Yeah.
But yeah, if you have any questions in mind, you can say in the chat.
Yeah. Leave any questions you guys have as well.
Yeah. So if you don't have K, I think you mean if you don't have the gradient, right? If you don't have the gradient, you cannot find the gradient in terms of K, then that's a bit. Then you can't do the rest. Yeah, I would say it is. So maybe 2013 the exam's not that friendly. Nah, it's all good. This is what this channel is for, right? Explaining,
Thanks.
helping people.
Cool. Drop any final questions you guys have, and then we'll probably end it there then. If you want to like share how your assessments have gone, I don't know, some of you might have had your oral exams or the
Yeah.
GAT, or what your next exam is. Or like how your SACs went. I'd be interested to hear. Otherwise, I'm happy to close it at 11:50.
Let's make it 12. Make
12?
it.
All right.
Yeah. For those of you who stayed, if there are anyone who stayed, 4 hours? It's pretty amazing. And yeah.
Yeah. Thank you guys for joining. And yeah, so the average view time was like 4 minutes, but like 2,000 people. So I don't really know how that works. Like
2,000 people.
it says like playback, so it might have been the same person playing it, but it's a lot of people. After the thing's done, I'll show you like how many hours people watched, and it's usually like a very long time.
Oh. Full mark comparative. Darn. That's well done.
Congratulations. Did my
Yeah.
videos help you much, Ace? Wait, how many exams do you have? Do you have like 5 or 4 or something? 3?
Neil.
Did you say 3?
No, were you asking me like how many?
Yeah.
Oh, I have 4.
Ah, okay.
Yeah.
Nice. I'll move us to the middle of the thing.
And maybe I'll just final like mark on the previous question 4C. Normally when we are asked to find the equation of the tangent, well, it only asks for the gradient, but it's really the same thing. When we are asked to find the gradient of the tangent, but where the point of tangency, like the point Q there, is not given, we can always set that point to be, I don't know, A F A or B F B or like that, or F G. Oh yeah, and then we keep working through the algebra, and then we find the equation of the tangent based on that the point that we set. So B, FB, for example, and then after we got that equation of the tangent, we can sub the value of the other coordinate in, and then we can find that.
Do you want to go through that question? Someone asked, the same guy, AJ, asked for a probability question in 2020.
Oh, I lost 2 marks on that. I didn't know how to do it.
Oh, was it that one? Oh, that one will like take a while to explain. I got it right, but like it takes a while to understand.
Yeah, I didn't know how to. I didn't know what that question mean.
Yeah, it was the one that's like 200 like lines, like a lot of writing.
I think, 2/9 or something like that.
Oh,
Well, suddenly at the end of the stream, it's like, how about let's just choose one? I think 20. Let's see, mainly exam 2s.
which one do you want to do?
Have a look.
Also, Ace, I would say it's easy to fall behind in uni. Like I'm a bit behind, in terms of lectures because, like, I have other stuff to do that I prioritize over uni. So yeah. How about you, Yichen?
Oh yeah, it's been like really, really stressful for me recently, like workload and all that. I've got a really hard like computing assignment coming up. Yeah, that was really hard. And all the other subjects I saw since it's coming to the end of the semester.
Are you on top of your lectures?
Only behind this week. I spent like most of this week doing the assignment, and I haven't got much chance to. Maybe two questions. All of these exam 2 questions are pretty long. Like, shit, 21 marks.
I mean, we'll probably do it another time. You can sort of just record like a short video or something discussing it, and I can just release it.
Maybe for one of your what do you call it, learning streaming time, we can do it.
What do you mean, learning streaming time?
Like, aren't you planning to do some live streams, just yourself studying? Maybe you can go do it there.
Yeah, sure. I don't think I'll do that much because it's a little distracting for me. But I
Yeah.
think we can probably do 2 or 3 more lives before their exams. So if you wanted to hop on for like just half an hour or something, do those questions. Yeah, we could do that as well.
It's for you guys. Because the exam coming up, right? And it's still like a month till uni exam, and that's manageable, I guess.
Yeah. It's pretty crazy, honestly. Like my actual uni exams are a week after the VC exams, right? But like I'm tutoring a lot of kids, plus I'm doing a lot of YouTube because like once the exams are done, right, there's nothing else to like I can't really help you guys once the exam's done. So yeah, I'm sort of prioritizing this kind of thing, these videos and these live streams over my uni a bit. And my students as well over uni. And yeah, this is just VCAR paper. Like you can just go to VCAR website.
I guess maybe we can answer like some like general questions, but not really method specific.
I'll just take a photo of those questions that people asked.
Yeah.
So I just remember 2016 exam 2 question 4 and then 2020 3F. Cool. Are your lectures like alright? I find my lectures so dry sometimes. I can't I get so bored when I'm watching them.
Yeah, the lectures are. Like you mean for uni?
Yeah.
For some of the recorded ones, have not good. Right.
Oh, a lot of your lectures live, right? Like you can watch them on like Zoom, right?
Hmm?
Some
some of it are live and some of it is pre-recorded.
now all of ours are pre-recorded, so it's like it's
Wait, hold
alright.
on, Derek.
Pun?
Hey, Roxanne, this is for you.
Oh, so it was someone. Was this the QRL person?
Maybe. I don't know. Oh, but now I realize. Okay.
2020 exams for methods. Yeah, I felt that. Like the moment I read the exam, I was like, they've changed whoever wrote the exams. Did you get that feeling at all?
2021.
Yeah, for methods.
I thought it's just one of the before ones, but without. No, I didn't feel much difference.
Oh, okay. I think Gordon didn't feel much difference as well. Maybe that's the difference between you guys and like me. But I felt like it was very different. Like a lot of the probability questions, like they've never drawn a binomial distribution in like a question before.
Oh, yeah, that was. I don't think I got that one correct either. Yeah, I tutor method and Spanish and a bit of physics.
Yeah. I tutor English, Inglang, and younger children as well.
Yeah. Public speaking.
Yeah, like public speaking, debating, spelling, you know. I teach them like new vocab and stuff. It's really exciting. Like I do feel like once you get to VCE, it is possible to do a lot better, but it's also a lot easier if you start early and you have like a history of doing well, good at maths and stuff. So it's been fun like helping the younger kids because you can set the foundation.
Yeah, I found the 2020 method to be harder than special. I
Yeah,
thought
I agree.
I would have lost less marks in special than method, but turns out
Did you wait? You didn't? You lost 5 to. Oh, right. You lost. Yeah,
I
you didn't
lost
get
5
like.
for special.
Yeah. Yeah, specials, you can probably tell by the marks. It was tight. Like you lose 1 mark and you lose like a study score almost, kind of.
It's crazy how Gordon only lost like 1 or 2.
Yeah, it's very impressive. You have same people in your classes? Yeah, you would, right? In Sem 2.
What do you mean?
Like all your Sem 1 classes, the people, do they change in
No.
semester 2?
Okay, so it's like a really, really large cohort, like physics and I know, like it's different subjects, right? For some of the subjects that I carry into second semester, for example, AM1 to AM2, then it's quite, it's almost the same, I'd say.
How big is the AM cohort?
I don't know, like with about a bit more than 100, I'd say.
Oh yeah, I did methods in 2019 and 2020, and Yichen did it in 2020.
Yeah.
How's your 12 going, Kianan? If you want to share, I don't really
Yeah.
know what subjects you're doing.
I didn't play much badminton.
Kianan's a violinist, I think, or some kind of instrument. I think violin.
Yeah, Darren can probably come back into the 2021st.
Get a 46 again. Yes. Are your tutoring kids getting like nervous at all now that exams are closer?
I only have one year 12 students. And
What
like
subject?
all the other kids that I tutor, mostly year 11, and they have their Chinese exam. They're worried about
Oh,
their Chinese exam. So, but my year 12 kid doesn't seem too worried.
oh, yeah, Chinese. Are they
Yeah. All the year 11 kids, right? Like they do whether SLA or FL in year 11.
Oh, so you have a lot of like sort of recently overseas kids.
Not really, like ABCs as well.
I don't have many Asian, I think. Like in year 12. A lot of my year 12 students are like not Asian.
Oh, Eddie, hello. Did you say hi to Mr. Patel for me? If you get to see him. Well, not get to see him, but
Ace, did you play any? Oh, yeah, Yichen, did you play any games? Ace asks.
yeah, I play any games. Back in year 12, yeah, after school, I would play games with friends. But the thing is, I can separate when to play games and when to have rests. I think when to have rest, when to play games, and when to do work. Okay, I can separate these two.
Wait,
That's why
what games did you play? I didn't know you played games.
I play some Chinese games. No, just like mobile.
Oh, like
No.
Wanzer Royale. Or not.
Or like some of the other games, like PUBG on mobile.
That's not really Chinese, is it?
Yeah.
I think there's some other ones. What was it? Do you know what score you needed for like 45 plus? So I got 46 and I dropped 2 marks exam 1 and like 7 or 8 exam 2. So a
I think
little lower than that.
about 9, about 9.
Yeah. Plus
10
my plus my SAC rank was really high, so that would have helped cushion me a bit. Did you leave a particular? Yeah, you did a VCAR exam like really close to the actual exam. I remember.
Oh yeah, I did method the day before 2019 method, like the day before the. Oh, I did method 2 days before the actual exam, and method exam 2019 exam 2 like 1 day before.
Were you not worried that if you did badly, you'd be like sad?
I think Jim did do the 2019 eventually because he was like, "Oh, I gotta leave it till the last week. I gotta leave it till the last day," and then he just end up didn't do it.
Jim did it in year 11 though, right? Oh, you're talking about special methods?
Yeah, I think it's special.
Oh, okay.
Whether special method. Yeah, I think I did both of the 2019 special method pretty late.
Am I gonna do a Latin video? I'm considering it. Is there any part of Latin you want me to do? Like, I'm still pretty good at Latin. I just recently started tutoring someone in Latin, and I've realized like I haven't forgotten like a lot. Um, so I mean, I'd be happy to do one. I think my last Latin video got like a couple hundred views, which is pretty cool, considering like how many people do Latin.
Yeah, well, Keanu, I don't have a PC like a good one, like a desktop. So yeah.
Yeah, I don't really have a history of playing games. I don't really have a PC either, so it's sort of like mobile games, and I quite enjoy them, so it's fine. Rando, I didn't drop 2 marks on exam. Oh, exam one. Yeah, I did. I just dropped one on like the log one and one on the how many solutions one. Maybe I dropped 3 marks, but yeah, it was just those 2 questions. Oh wait, no, that was 2019. I didn't 2020. Oh, I also dropped 2 marks actually. I thought the 2021 was conceptually hard, but the maths wasn't that hard. Do you remember it?
Which one?
2020, the one we sat, exam one.
Oh, like method?
Yeah.
I think it was alright. It's like same standard as before.
You dropped like 1 mark, right? Exam one.
Nah, exam one.
You dropped what?
Full mark exam one,
Oh,
and
okay.
I all marks on exam 2.
Oh, how's your love life? Yichen.
What?
Um,
It's I don't know. I wonder who is that.
yeah.
I wonder who that is. But yeah, it's pretty good for me. What about your love life?
I don't really have one. I'm in a love life with myself.
Love life of the subscribers.
Speaking of subscribers, let me check. I think I was pretty close to 1,900, like just then.
Yeah.
Oh, I hit
Hit
1,900.
that 2K. Hit that 2K for it.
I hit 1,900, so thank you guys. Really appreciate it. Like just then. So thank you.
Do you accept cash for tutoring? Well, you can't really have cash with this lockdown, right?
Do you do practice exams? For me, I didn't. I don't think it's that bad of idea. I would probably do one if I did VC again. Probably do one like 2 days beforehand. Um, but I stopped like relatively early, maybe like 5 days or even a week, because I didn't want to sort of impact my thinking and psychology, and I wanted to be able to learn from my exams, and I didn't think like a couple days was enough. But now looking back, I feel like it would have been a good idea, so I don't like lose my edge.
Yeah, we're in love life with our exams.
Yeah, laugh at us for being nerds, yet we help you guys on the live stream. So, there's, but I guess nerd is not necessarily a bad thing.
Really, I always kind of treated it as a derogatory term.
Yeah, it's traditionally a derogatory term, but I feel like it's being reclaimed. All right, we'll see any final questions, and then I'll really end the stream. All right, by 12:06, if there are no new questions, I end the stream.
I like how towards the end, the more people
Yeah.
coming in.
I think at one point we had like almost 70 people, which is pretty cool. We had like 68, 67 at the start.
We giving a lecture.
4-hour lecture. All right, so I think I'll end the stream then. Thank you very much to Yichen for joining us for exam
So
tutor.
good. Hopefully, you guys can learn something from it. Yeah, see the method exam techniques, and hope you guys will do well in the upcoming exam.
Cool. I'll just take a photo of AJ's thing. Yeah, the last question. Right, yeah, and as always, like message me, message Yichen, if you have questions, or for me, like if you have video requests or anything like that.
Just comment below Darren Tan's YouTube channel.
Cool. All right. See you guys. Oh wait, one question. Do you recommend to mark your exams right after? What do you do?
What do you mean mark exams right after?
Like, did you correct it straight afterwards, or did you wait a bit?
Like practice exam.
Yeah.
Yeah, I corrected right after. What's the point of waiting like a couple of days to? I normally just exchange and then we'll mark for each other.
Yeah. I mean, if you don't like mark it right after, sometimes you forget like what you were thinking and stuff.
Like actually, if you don't mark it, there's no point if you doing the exam. I think you don't know your mistakes. You can't really learn from them.
Although, thank you, Brendan, for commenting. He's a big supporter of my channel. He's in med as well. Yeah. Thank you very much, Brendan. All right. I'll end the stream then. See you guys next time.
All right.